a discussion on this important area with key practitioners in the field to share their experiences with the stakeholders. So we hope our resource persons will share their experiences with us, with you as well, and also you also can share your experiences with us. So I'm not taking much time in this regard, so I'll like to invite Professor Ranjit Senaratne, Chairman of the National Science Foundation, to welcome you all for this event. Thank you.
Good afternoon. Dr. R.D. Gunaratne, Chairman of the Working Committee on Science, Technology, Policy Research, and the resource persons join this event. Dr. Sepali Sudhasinghe and members, invitees, and those who are joining online from academia, R&D institutions, and industry. First, I wish to express my gratitude to Dr. R.D. Gunaratne and the members of the committee for organizing this very important event titled Current Status and Future Trends of Application of Technology Related to the Fourth Industrial Revolution, Sri Lanka, mainly a discourse by practitioners in the field. So it is not just an academic exercise, but it is really of great practical relevance. We know this 4-year has become a household term, and it has already made tremendous impact on economic development in many countries. I think in Sri Lanka, though we have high potential to benefit from this, I think we are still reaping only about small fraction of its potential benefit. In fact, this 4-year is a fundamental extension of 3-year, third industrial revolution, and closely interwoven with ICT. If you look at the economy of our country, the digital component is, I think, less than 5%. But in Malaysia, it is more than 30%. They are really harnessing this 4-year to enhance their economic growth, their development, even every business to enhance productivity, efficiency, these tools being used widely. And we are planning to make Sri Lanka a developed country by 2048, before 2050. In that context, 4-year has great relevance and value. My task is to welcome you. Dr. Gunaratne has identified, assembled a high-profile team with hands-on experience in this field. So my primary task is to really extend a warm welcome. Of course, first to Dr. R.D. Gunaratne, and we have Dr. Ramesh Ranavana, CEO, Enterprise Machine and Learning Private Limited. We have Mr. Nuwan Senaratne, independent consultant, and with customer experience, hands-on experience. Mr. Jeevan Jnanam, who is already working closely with us, is the one having the largest incubator and the accelerator in our country. And then Dr. Rohan Veerasinghe, who is also very near and dear to us, is from University of Colombo. So on behalf of the National Science Foundation, I extend a most warm and cordial welcome to all research persons and those who are joining this webinar, this discussion on site and online from academia, R&D institutions, and industry. And we are very happy that there are participants from industry because we want to really forge mutually rewarding strategic partnership with industry. I think Dr. Gunaratna, at the end of this, I think there would be, I'm sure, some discussion would be emanating from this. And as you know, many countries, even now Vietnam, they have constructed a roadmap how to become a developed country, right? So each country has really constructed roadmap. I think we are not really embarked upon constructing such a roadmap. I think it is nothing but appropriate, especially NSF, Apex institution is Santee, take the lead and assemble a team to really attend to this important task in constructing roadmap to make Sri Lanka, to transform Sri Lanka from developing to developed country. I think it's probably a beginning of a long journey. And today, I think laying foundation for that journey. And I wish this delegation all success and look forward to receiving recommendations from Dr. Gunaratna and the team. And you know, Dr. Gunaratna has considerable experience, knowledge, and expertise in this field. So I am sure he would provide necessary leadership, guidance, and direction to the discussion. And I wish this important event success. Thank you.
Thank you, sir. According to our next item, Dr. Gunaratna will give you introduction remarks why we have we are organizing this particular event, and for that I would like to request Dr. R.D. Gunaratna, chairman of the Working Committee on Science, Technology and Policy Research, and he is former Director General of National Science and Technology Commission. Over to you, sir.
Thank you, Mr. Anuruddha. Chairman, Director General, resource persons, and guests. I want to tell you a little bit about why we are here today and what we hope to accomplish by 5:30 this afternoon or thereabouts. Now, it's been about 15 months since the NSF did me the honor of appointing me to chair the Working Committee on Science and Technology. And when I accepted the position, I had to make some decisions about what the agenda of this working committee could reasonably be, given, of course, the circumstances. And the circumstances, as you all know, in the middle of 2021, was that we were still not past the turmoil caused by the pandemic, and there were some additional economic storm clouds on the horizon that were clear to those of us who had eyes to see. And as we all know, those economic storm clouds eventually became a hurricane. Now, in the middle of such a crisis, I was only too painfully aware that governments, whether politicians or bureaucrats, do not take difficult decisions to invest heavily in science and technology when the country as a whole has a very poor track record of doing so anyway. So I decided that rather than study anything that would be effective only over the short term, whether it was going to be policy or something else, I would look for something that was more medium term and even more long term. And the first thing that really came to my mind was the fourth industrial revolution, which I had been looking at for a while. And I realized that the world as a whole is now in it. We are in the middle of the fourth industrial revolution. But Sri Lanka as a country has barely got its feet wet. I think the chairman, Professor Senaratne, alluded to the same thing when his comparison between Sri Lanka and Malaysia. So I made a recommendation to the NSF board that my working committee would study the fourth industrial revolution and some aspects of it. And the board agreed. And so the fourth industrial revolution, of course, while there are many, many technologies that contribute to it, is really spearheaded by artificial intelligence and some key related technologies like robotics, big data, and the Internet of Things. And this is obviously something that could contribute to ideally rapid growth and certainly dramatically increase productivity in our industry in years to come, and did not really require an immediate action by the government, which I thought was important. So I had to start by assembling a group of people. Some members of the committee had already been appointed. And I took a bit of a gamble. And I asked Dr. Ruwan Weerasinghe to come on board, knowing very well that his assistance, his collaboration in this project was absolutely crucial and that I would fail without it. Well, it turned out not to be too much of a gamble because he did join me and he has given me his fullest support, and I want to acknowledge that fact now. So with his assistance, we put together a subcommittee that would deal with aspects of the fourth industrial revolution. We had several meetings. And a suggestion was made, and I want to acknowledge Professor Priyan Das as the originator of the suggestion, that we should find out what actually works in Sri Lanka and what does not. In other words, we should listen to some success stories and perhaps even negative experiences that people working in this field might have undergone. And that, ladies and gentlemen, is why we are here today. Right? So we decided to have a symposium, if you will, where we would invite people who, mostly private sector people, who worked in the field of artificial intelligence and the related technologies to come and tell us their stories. And from those stories, I hope that we can extract some idea of what works, what does not, what government policies are needed, what government policies are not. I'm well aware that in areas like information technology and artificial intelligence, the industry, the cutting edge of the industry is way ahead of any policies that a government can come up with. But at the same time, particularly those of you in the private sector might be well aware of this, your activities are affected by government policies, sometimes positively, sometimes negatively. So we need to have some idea of what the barriers are to success, as well as what activities on the part of the government, what initiatives would actually promote our goals and help us achieve these advances in productivity that will be crucial for the development of this country in the years to come. Right? 5 years from now, 10 years from now, 20 years from now, we will need this. So we had a serious discussion. We identified resource people. We are very grateful that they accepted our invitation, and here we are today. And I hope that at the end of today, the objectives that I just outlined will have been achieved to the extent possible. I would like to conclude by thanking the NSF, its chairman, its director general, its staff, and particularly Mr. Vasanta Anuruddha and the staff of his section, who have worked very, very hard to make this event a success. I'd like to thank the resource persons, particularly, of course, Ruan. And I would like to thank all of you for being here today. Not only, I hope, as an audience, but in the discussion section, I welcome your contributions as well. You also may have had experiences that you can share with us that will be valuable. So with that, I don't want to take up any more of your time, right? Ruan is the chairman of our subcommittee, and I'm going to turn over the rest of the afternoon to him. Thank you very much.
Thank you very much, and welcome to everybody. Good to see some people I know. I think the resource persons feel a bit like the proverbial 6 blind men who were asked to describe an elephant, right? So depending on which part they managed to grab onto, they had a different idea of what the elephant was. And so in a way, 4IR is a large area, but the distinctiveness of this group is that they've all got their hands dirty. They've all done something. So we're going to have the 3 main sessions. One is Dr. Ramesh Ranavana, and he's got a lot of experience in actually doing some things, and he's doing something else now. I told him to just explain a little bit about what he's doing now, but what he's doing now is, if you like, a little out of scope for this this particular presentation, but that's where things are heading. Then Nuwan Senaratne here is probably the person I have seen who actually I don't know. He seems to have all the data, right? And I know that this government data is normally not there. It's not there. We all know, right? Even the data, I think I've told NSF also. The NSF sometimes requires us to return our laptops, right? That we got from the research grant. But the laptop is useless. I mean, after 3-4 years, it's for e-waste, right? But they don't, and they also want our papers and all that. But they never asked us for the data, right? But the data is the crucial thing, right? So the data is kind of with every researcher, they just have it with them. The paper is there published, but the data is not available. I mean, unless you're in some areas such as bioinformatics where to publish, you need to make your data available. And so no one will talk about some of his experiences about doing that and how that leads to better decision making, evidence-based decision making. And then Jeevan, yes, I think the chairman said NSF works with him, and but as you know, he's a person who's always on the run. And so there's a trade delegation right now at Orion City. So we are hoping still that he will be able to at least join on the link, right? But what I wanted him to talk about was the ecosystem, the AI ecosystem in Sri Lanka, which is at a nascent stage, and he plays a key role because. Not just Orion City, but he has a thing called, he is a co-founder of a thing called the Hatch. And so maybe during the discussion, depending on his unavailability, since Nuwan here also has some ideas about the way Hatch works, we may be able to talk a little bit about that. And also, of course, Jeevan has his own companies, I think about 2 or 3 of them, dealing in different aspects of AI. And then I'll talk at the end because Priyan forced me to talk something about what I do. And that's about something called large language models. And I'll introduce that when I talk. And then the most important thing, as Anuradha said, was that this is a discussion. So some of you I know, people in the industry, people in government, people, individuals who have done things related to IT and AI. So also those who are joining us online. And so we have someone manning the online thing for questions and comments and suggestions, and of course the live audience also. And so we are really looking forward to that. And depending on Jeevan's timing, we may actually have more time for that kind of exchange, because as the chairman and Dr. Rani Gunaratne said, the main purpose of this is to come up with some kind of a way forward, whether it's in terms of guidelines, in terms of roadmaps, in terms of policy maybe. Right. So without much ado, I will ask Romesh to come and start his talk. The point has the slide next to it. Oh, sure.
Okay. So, good afternoon, ladies and gentlemen. It's wonderful to be here and actually have these discussions going on in Sri Lanka, because, like was pointed out before, it's a huge need in the country at the moment, and we as a country, even though we have one of the most educated populations in the world, we really do lag behind on the technology front. We and that can be seen right across the board in a lot of things that we do in Sri Lanka. I mean, if you take my field, which is artificial intelligence, Sri Lanka at the moment in terms of AI innovation ranks about 100 or 110 in the world, which really surprises me, because to build capacity in something like artificial intelligence, you don't need to make huge capital expenditure. You don't need to buy huge equipment. You don't need to, set up huge laboratories. Or, I mean, now the technology has advanced to a point where you can collect data, build a model, and deploy a model all on your mobile phone. It doesn't really take all that much. So the question is, why haven't we advanced on that front when countries like Rwanda, Kenya, Nigeria are all ahead of us? And even if you take the regional countries, Malaysia, Cambodia, Vietnam, they are significantly ahead of us in terms of capacity and what they've done, and more importantly, the results that they've achieved with artificial intelligence. And that's a lot to do with so the thing with AI is that artificial intelligence has been a subject of conversation now for more than 50 years. The algorithms that we use now in neural networks and all that were invented in the 1950s. And they really haven't changed all that much since then. The big difference that happened within industry, what brought AI to the forefront all again, there were a couple of failures over the last 30, 40 years, but now it really is a big deal. And the reason for that is that because of digitization that happened over the 1990s, the early 2000s, what we had was a collection of huge amount of data, which when these systems came about in the 1950s, that data was not available. You really couldn't make full use of these systems because you didn't have the raw materials to put these systems together. And then the big change which happened over the last maybe 15, 20 years was computing power became cheaper, which meant that you could put these very, very large, I mean, building a machine learning system with lots of data requires huge computing resources. And if you look at the resources that were available, say even 20 years ago, those resources are now, you know, 1,000,000 times cheaper than what they were. And especially now with cloud computing, it makes these resources easily available and easily scalable. You don't need to be making 100 million rupee investments to be able to build the capacity to do that. I mean, just an example, when I was doing my PhD, my biggest problem was running my experiments, training my models. So I was doing my PhD on identifying promoters and genes in DNA. And I had this data set of, you know, a whole bunch of DNA sequences, which I was training my neural networks on. And each training run of a neural network on the machine I had at my university at the time took me about 3 or 4 hours. And for my PhD, to run all the experiments that I needed to run, I had to run about 5,000 experiments over my 3-year PhD. And if I had done that on my laptop, it would have taken me about 15 years to complete my PhD. So it was just not feasible at that time. So really what I did at that time was I stayed back during one Christmas break when everybody left the university. I wrote a script which basically accessed about 3,000 machines around the university. And I ran all my experiments over one weekend, which I finished first thing. And that was really, at that time, that was the only way that we could run machine learning models. But now I could do this from home, you know, log on to AWS, log on to Azure, log on to one of these platforms and run this. What took me 3 hours will probably now take me about 2 minutes to train with that amount of data. So that's how far this whole thing has changed. So, and then the big change has been that the field of AI has evolved from being primarily an academic subject, which is what it was for the first 50 years of, you know, when AI was used, to now becoming an industrial and engineering subject. Now the focus is not about getting a data set, building a model and proving that you can classify something or get something right. Now the challenge is how to build something into an application, into a cloud portal in the same way that we build software systems. If you look at the evolution of computer systems, what you had over the 60s and 70s evolved into software engineering because there was a need for these systems to be built in a way that they can be maintained and evolved over time. And that's the only way that software is useful. So the field of software engineering, when you take from the 70s, 80s, 90s to now, has evolved significantly from, you know, the different methods that are used on how we modularize software to object-oriented programming. Those are all built to be able to make these software systems more useful over time, and they can be maintained over time. And now the challenge is, how do we build these machine learning systems in such a way where you take it out from the lab, where you have a model that you have trained, but then how do you make it into an application that's useful for the public in whole? And that usually means in even the most simple machine learning application where you're maybe trying to classify a mosquito with a photograph, you still got to build the software that will capture the photograph on your phone. You got to build the software, you got to build the system that will run your machine learning model on the phone. You got to build the software that will classify it and show it. You got to build an application. So whatever machine learning system you build, if you're going to take it into production, you usually have to build that larger system around it, which is what makes it into an application. Usually when you make it into an application, the machine learning part usually constitutes maybe 10-15% of that whole system in terms of the amount of engineering you do and the amount of code that you write. And that is where production engineering comes in. And that's where this new field of AI or machine learning engineering is now come to the fore. And that, unfortunately, is a skill that's severely lacking in Sri Lanka. I mean, I was quite surprised. We did a survey recently, and we found that about 70% of computer science projects done by our students in the universities have some sort of AI or machine learning component. But very few of those actually end up being an app or a web application or something like that, because we just don't cover that machine learning part. The general impression, even in the universities, is that you get a data set, you train a model, and you show some numbers, and you're done. We have to go beyond that. we have to train a new generation of AI engineers who can, number one, build scalable data, quality data that can be used for these systems, but then also build these machine learning models and deploy them into real world applications. And that's when we start to see it. And that's when the community will start to see the benefits of these systems. So, and that's, as Dr. Ruan said, that's what I'm doing at the moment. For the last 5-6 years, I've been really focusing on production grade machine learning and AI. And I've been running several programs in Sri Lanka along that line, which I'm happy to note that we've just, for the first time at Peradeniya University, we've launched 4 new courses, which are now going to be focused on machine learning engineering, where we're going to talk about, scalable data, scalable model production, scalable deployment, and how to put these systems together. And I do hope that more universities in Sri Lanka will start to offer these courses, because these skills really don't exist. And the kids learn this when they come into industry, and it takes them a good 3-4 years to get their head around how to put these systems together. But today my talk is slightly different. A few years ago, I worked with a couple of startups, invested in a couple of startups which were working on drone technology. And once again, we had this challenge of, everybody talks about drones, the utility of drones, but the real power of drones comes in with when you add AI to these systems. But once again, when you come to drone systems, the drones and AI, the challenge once again is how do you integrate, first is how do you integrate AI systems into drones, which in itself is a challenge. But then how do you integrate these systems into drones in such a way that they're built using proper software engineering principles, and also these systems can be monitored so that you can adapt these machine learning models over time as the environment changes, your data changes, and all that. So today my talk is really just to give you a brief glimpse into how AI is used on drones, and something of a high-level technical overview of what are some of the design models you can use to integrate AI systems into these drone-based systems. So really, the crucial element of UAV technology, what will take UAV technology to the next level is autonomy. If you still have to have pilots flying these drones all the time, that still severely limits how much you can do with a drone, because it takes time to fly, it takes time to train pilot, it takes time to, for the pilot to get to a certain place, carry the drone. There's a limited number of pilots, and flying a drone is quite a skill-based thing. So one of the backbones of the proliferation or the advancement of UAV technology is the ability to bring in more and more autonomy. How can you get the drone to work on its own without a pilot? But then the problem is that it is extremely complex. On its own, a drone system on its own is very, very complex. But then how do you add AI technology as well, AI capabilities onto a drone? So that's what I'm going to talk about today. I'll talk about, what are intelligent industrial UAVs, and how do we look at drones from the viewpoint of industry, from the viewpoint of companies. And then I'll move on to giving you a very brief overview of how to put the architecture together on how you can integrate some of these systems into drones. So if you look at how, once again, stepping away now, like I said, I've got a very unique viewpoint on the AI because I started my career in academia. I did my PhD and then I worked in a university for 3 years doing AI research. So I was a proper academic at that time. But then over the last 16 years, I moved into industry, and then I've looked at all this software in a totally different way. So I've got that dual viewpoint of being able to look at this technology from an academic's perspective, a researcher's perspective, but also from an application perspective. So really, when I look at drones, when I look at the capacity of drones, I look at it in terms of how can it bring more autonomy into my operations. So one, very simply, AI technology allows me to bring in vision, which is to be able to look at something and identify what that object is. It also, AI technology allows me to do voice recognition, natural language processing. It allows me to do robotic actuator control. That means you can actually manipulate things with machines. And finally, You can do knowledge representation, cognitive reasoning, and decision making, which means that basically now with the different modules, the different technology that's available with AI, what I can bring on to machines is the ability to see and understand stuff, the ability to hear and understand stuff, to be able to manipulate objects using robotic manipulators and all this stuff, and also to think about it and come up with decisions and conclusions on what's there. So basically what we have here, all the basic ingredients of a normal human being. You can now do with AI technology what you can do with a human being. All the stuff that we thought that we had to have a person for earlier, now we can do with a drone. But then what makes drone technology and AI even more exciting is that drones and technology or robots or whatever can sense much more than people can. It's not only what we can see with our eyes in the natural light spectrum. With drones now, you can use things like multispectral imaging, thermal imaging, LIDAR, infrared imaging, lots of stuff like that. So the ability to sense and detect and act on stuff is much greater when you grow with drone systems. So when you take those human abilities, the ability to see, the ability to think, the ability to hear and understand, and the ability to manipulate stuff, you add that to 5G technology or 4G technology, which allows you to do it at distance, where you don't actually have to be next to it or connected with wires. And that when you add to deployment platforms like robots, rovers, drones, even cloud platforms, whatever, what you have is now an entirely new world of opportunities on the type of stuff you can do. Anything that you thought 10 years ago, 15 years ago, that you had to have a person there to do this, now what we have is the opportunity to be able to automate that and replace those people with machines, which are just not thought of before. And that what AI is opening up is now a total new paradigm on the types of technology that you can build and the type of jobs that technology can do. So today's talk really is more about drones. Just think of having the abilities of a human on a machine that can go anywhere in the world, vertically, horizontally, anywhere. It just opens up a million different opportunities. And also, because of 5G and all that, what we also have is the ability for these systems to collaborate with each other, which once again then opens up a different sense of opportunities, both in security, agriculture, you name it. So once you put all these capabilities together, what you have is the ability to build some amazing applications using UAVs. You can build stuff for construction sites, from anything from actually doing the construction to monitoring it, to doing the defect detection. You can do all that with drones, which if you were to do that with people can be extremely dangerous, can also be very expensive to take it forward. Smart cities, so many 1,000 different applications you can do with smart cities. Drones are also used a lot now in emergency situations to go and find people, to detect threat levels, to detect landslides, stuff like that. Farming, once again, is a huge application where there are applications in drones all the way from planting, fertilizing, to monitoring, to harvesting. All that's being done with drones now. You have, once again, thousands of applications in military and defense, which once again, the earlier perception was you had to have people to do certain tasks. But now with drones and AI technology and robots, you can automate a lot of those monitoring, surveying, patrolling type activities with these systems, and also industrial infrastructure. So all this puts together, what we have is a subset, a collection of different types of UAV applications that we can build, putting together what's available now in drone technology and AI technology. You can build fully autonomous systems. That's one of the main types of applications of AI that you can do with AI and drones. You can have payload controllers. A payload on a drone is anything that's attached onto a drone. It could be a camera, it could be an arm to harvest crops. It could be anything that's attached onto a drone and used to do a particular task. Those are called payload controllers. And still, most of these payload controllers are manually controlled by somebody on the ground. But now we have systems being built where even the payloads are being automated using AI. AI is also being used quite a lot to do analytics of the data streams that are coming, the leader feeds, the camera feeds, the sound feeds. You can do analysis on that. You can build semi-autonomous systems. That's slightly different to fully autonomous systems, where the system is fully autonomous, it works on its own. But in the semi-autonomous system, parts of the drone will be controlled by the AI, parts will be controlled by a human. We also have more and more what are called robo-advisors, where the AI will run on the side. You still have a human operator, but these AI systems will provide guidance and support and advice to the person operating it so that they know things are going wrong. I mean, like it's done in medicine now. Very rarely would you find a fully autonomous medical application using AI. That's just too dangerous to do. What you would normally do is you would have an AI which would provide suggestions to a doctor, and the doctor would make that final call on how the patient should take it forward, and also things like emergency management. Especially just to get out of this, just to take a bit of a segue here. One of the biggest obstacles to the proliferation of drone technology at the moment is regulation. In terms of technology, in terms of the components, in terms of the skills, it's all here. It is now not hard at all to build a drone that can fly to any one of your houses, land, put something there and come back to Colombo. It's not hard at all. The GPS technology, the drone technology, the battery technology, it's all there. But what's not there yet is regulation, because it is too dangerous to be able to allow hundreds of delivery companies and all that to be able to flying around, delivering stuff around Colombo, because any one of those drones could be hijacked and be used for something bad. So before drone technology can take off, any country needs to have regulation which will manage how this drone ecosystem is going to work. How are you going to get permission for a flight? How is your flight going to be tracked? Just like which happens with aircraft. Without that, it would be just too dangerous for a country. So really what's holding the whole drone technology back right around the world, I mean, Amazon has been talking about using drones for deliveries now for years, but it still hasn't really happened. And that's because the regulation is not there. And we have several countries around the world now who are trying to build very extensive drone regulation. On one side, define who can fly drones, what they can fly it for, and also set up IT systems where people can very quickly get permission to fly a drone, upload their flight plans, they know where they're going, and set up this whole ecosystem so that you can innovate and do stuff very, very fast. And countries like Singapore, US, and Europe are quite a way down setting up this regulation. But quite surprisingly, one of the leaders in drone regulation in the world at the moment is India. In 2016, they set up probably one of the most extensive drone regulations in the world, because they realized that drones were a big part of their future, and they had to set up that platform on to allow these people to fly drones. And now in India, they have an app. Anybody who's registered on the system can get permission for a flight within, I think, about 30 seconds. Whereas in Sri Lanka still, if I want to fly my drone, I still have to send an email to the authorities, and with GPS coordinates, images of the area, Google Maps, and all that. And I usually get a reply back in about 3 days if I'm lucky to get permission to fly. And that's also only for that particular location for about a half an hour, 1 hour flight. So that's just too hard. If you're running research, if you're experimenting and stuff, you can't do stuff like that. We have to set up more regulation to manage, and also set up maybe industrial parks, R&D sites, where people working on drone technology can go there, fly their drones, do their research without having to jump through all these different loopholes. And that India did 6 years ago, and that's why they're so far ahead of us. Anyway, coming back to AI and UAVs, move on to my next section, which is how do we build intelligence into these drone systems? So really, the big challenge with drone systems is two things. One is data from the sensors, the cameras, the payload, the telemetry, all that have to be fused together. What you have in the drone is a system which has multiple inputs coming from different places. You might have cameras, you might have sensors, you have the flight controller, how fast are the propellers spinning, there's so much data coming in. So one challenge is, how do you bring all this data into a single system on the drone? Because remember, the problem with the drone always is that it's a limited platform. It's a limited platform with a particular weight. If you add anything to it, if you add any new processor, anything that adds to the weight. If you add any new processors, that also means that you need more power. More power means either with the existing battery, you lose the amount of time that you can fly, or you have to add more battery. When you add more battery, it makes it more heavy, which means that it can't fly as far away. So you're always limited with the amount of technology you can load onto a drone. So one of the big challenges is how can you do what's called sensor fusion? Sensor fusion is how can you get all this data from right across the drone, bring it into a single place so that you can manage it. And that's what, to bring autonomy into a drone. First thing is, how do you bring data from the payloads, the cameras, the leader cameras, the landing gear, everything? How do you bring it all into a single place so that you can make decisions on what to do next? So that's one big challenge. And then the second big challenge is when you have an AI model, either a vision model or a language processing model or whatever running on your drone, what's the procedure, what's the hardware, what's the platform that you would use on the drone to run that particular AI system? So those are usually the two challenges. One is sensor fusion. Second is how do you actually run these AI systems? So if we move on to the AI module, there are two types of ways that are typically used to train these AI systems. Using the standard ways, which is supervised learning. In supervised learning, what you do is you go out, you collect some data, images, whatever, using the actual drone. Then you bring those images back. You would get somebody on the ground to manually label these images, and then you would train your system and you would load it on your drone, and that's how you would run it. So if you're building things like people detection systems, security systems, agriculture systems, the usual traditional way is to go out, collect some images, label them, train a machine learning model, load it on the drone, and you got a working system, and you got to continuously keep improving that. But that method only works if you're building things where the data is easily accessible and it's easy to label them. If you're building things like autonomy means you're trying to build a drone system that can navigate around the field, navigate around people. That method is just not practical because there are so many different variances in what can go on in environment. It's just not practically possible to go out and collect all the possible data that's necessary to be able to train a system like that. So in that type of situation, you have to use some form of unsupervised learning. And the way we normally do it is autonomy-based systems are usually trained within simulators. You have to build a simulation environment which will represent your working environment as closely as possible, because it's something like autonomy is not something that you can go and play around with and learn as you go. Because when you're talking about a drone, if your autonomy system doesn't know how to recognize a tree, first time you fly, every time it's going to go and crash into that tree, which means that you're going to have to buy a new drone every time you run a test flight, and that's just not possible. So when you're talking about those type of AI systems, the step one is usually how do you build a simulator environment which is as close to the real world as you can, and then you try and fly your drone within that simulator environment, and you get it flying, you get it working within that simulator. Only when it's working up to a certain level that you then load that software onto a real drone, and you get that and you start working on that environment. So that's where you have unsupervised learning, where you create a simulation environment, you define the goal and the conditions, and you use things like reinforcement learning, those different types of systems to get it there. So once you have this model built, if you look at the workflow of how all this would work in a UAV system, what you would have is, you have the drone, which would have, a set of camera feeds, a set of sensor feeds, and you would also have all the UAV telemetry. UAV telemetry is the GPS location, how fast the motors are flying, what's the battery level and all that. All that is sent into a system which should do the sensor fusion. That means bring all this data into a single platform so they can be all accessed together. Then you have some system on board which will execute the model, whether it be a vision model or a language processing model or a leader detection model, whatever. You would have some sort of perception. Once you identify that, you got to understand what this is. The drone would make some sort of controlled decisions, fly left, fly right, go up, go down. I need to land now. It's got to make some decisions at that point. And then finally, once you make the decision, the drone then has to send a command, which will then make the drone do what it decided to do. So that's the usual flow. You have to collect the data, put it all together, run it through a machine learning model, understand what it is, decide what to do next, and then send the command back into the drone. So it will do what you wanted it to do, fly left, fly right, go up, go down, capture something, go and harvest this leaf, go and pluck this leaf, whatever control. So this is the challenge in building a drone system. How do you build all this into a drone, into something that's severely limited in the amount of power you have, the amount of computational power you have, the amount of room you have on the drone to put all this? These are the challenges. So what I'll do today is I'll give you some idea of how this is done. Some of the models that are used to do this. So like I said, the two challenges here is one, sensor fusion. You need some hardware on the system that will bring all this data together and put it together. And then finally, the model execution part. How do you run a machine learning model where you can send in an image and it'll tell you this is the leaf you should pluck, right? That's where the model execution comes in. So really the challenge is this. All modules, all AI modules on any AI module requires computational power. It requires a lot of computational power, depending on whether you're running the complexity of your machine learning model, you need more and more computational power. But then in a drone, normally when we are running this on our laptop or on the cloud, we don't really think about this. But when you're running on drones, something that you really have to think about very carefully is power. Because the power comes from a battery, and the larger the processor you use, the larger the GPU, it's going to drain your battery like this. So that's the challenge. You got to balance between your computation power and your power requirements and the weight of the drone. You got to come up with that balance for that particular application. So really, depending on your application, depending on the type of application and the latency and the accuracy, so many different factors, there are three main ways that we would deploy the machine learning model. One is where we would run the machine learning model on the drone itself. The second would be on a ground station where something connected onto the pilot. And the third is, something based around a cloud system. And I'll quickly walk you through those three models. So why would you want to build AI into a drone itself? Why would you want to run it on a drone? So three possible reasons. There are certain things which require real-time processing. Real-time processing is like navigation and autonomy. The drone has to make instant decisions, like if it's flying around, it sees a tree and it decides to turn left or turn right to avoid that tree. If you had that running on a cloud, the amount of time it takes for the command to go into the cloud and come back might just be too much. It might have already crashed into the tree at the time. So there are lots of applications where you need real-time decision making on the drone, which means that you need to run these AI systems on the drone itself. There are also environments where connectivity is bad. You may be flying in a jungle, in a rural area. Your application might be there, and if your AI model is running on the cloud, once again, then your drone is not going to work there. And then there are things like security implications. For security, whether you would want your telemetry going onto the ground or onto the cloud, because somebody could intercept that data and hijack it and use it for something else. So these are just three possible reasons why you would want to run your AI models on the drone itself. So the first thing that I said is you need to be able to do sensor fusion. How do you bring all this data together from the different areas and run it on your drone? So usually we use simple hardware like Raspberry Pis and Arduino boards to be able to do that, to do the sensor fusion part of things. And they're usually enough as long as you're not dealing with high definition video data and all that. But anything else, these boards are usually more than enough. But then in terms of running the AI model, this has been a large area of research over the last 5-6 years, and we've seen huge advances where more and more of these small special purpose chips are coming out for running AI models. And these are probably the three most popular ones going around at the moment, which is the NVIDIA Jetson Nano or the Google Coral Edge TPU or the Google Coral Edge USB, where all three of these are specialized boards where if you have a machine learning model, you can run that machine learning model on this board. Where all three of these are built with dedicated GPUs or graphical processing units, which allow you to run these machine learning models very fast and very efficiently. But they all consume about 2-3 watts of power, and you can run it for a long time. So these are some of these systems that are now becoming available, where you can actually run the AI model on the robot or the drone itself. So if you look at how a normal drone system works, what you have is a flight controller, which would control the propulsion. You would have all these different payloads, LiDAR sensors, sprayers, landing gear, cameras. Those are all connected to each other, to the flight control and the control hub. Usually you have some sort of control hub, and this is where I said you would use a Raspberry Pi or Arduino chip. And then this would all be connected onto some sort of comm system, radio system, which would beam all this information down to the pilot. But then you also have power. So the battery needs to be connected onto the propulsion system, the flight controllers, the control hub, the sensors, and all that. So if you were to add AI to this system, what you need to do is to take your AI hardware and usually link it directly onto the control hub. So this is where this control hub is even more important when you're running AI systems, because if you didn't have this control hub, you would then have to connect your AI hardware separately to the flight controller, to the propulsion, sensors, all that separately, which would make it hugely complicated system to manage. And this is usually this is sort of the architecture that you would use if you were putting a drone system together with onboard AI processing capacity. Second option is if you were to deploy your AI processing on the ground station. The ground station is the controller that the pilot would use to pilot the drone. And there are certain situations where there are lots of applications where running your AI module not on the drone but on the ground makes sense. For things like pilot aids, where you're providing aids, graphics, direction to go, all that. For the pilot, there's no reason to run that on the drone. You can run it on the ground station. Real-time analytics and insights for the pilot, and some level of high-level autonomy where you're only giving directions to the drone. So that's an option. So in that situation, what you would have is you would have this ground station which is connected onto the drone through radio frequency, Wi-Fi, 4G, 5G, whatever. And the ground station would have all these different things that will allow the pilot to control the drone, the payload controllers, the displays, and all that. And then what you have is you just have your AI processing hardware connected onto that. The final one is not really relevant to this one, but I'll just quickly go through it for completeness sake. But if you were running your AI modules on the cloud for some particular reason, where you're working in a particular environment with 5G, that's one of the big reasons why 5G is very important. 5G allows very, very fast communication between these devices and this thing. So there will be more and more applications where you can run your systems on the cloud. And in that, what you would have is the drone would be connected directly onto the cloud. The ground station would be connected onto the cloud. There would be a link between the UAV and the ground station. And what you would have is once again your AI hardware running over there. So really, to end my talk, that's my main take-home message here is that AI is the secret ingredient on what's going to take UI technology to the next level. But for that, a lot of things have to come in place. One is regulation has to come in place. One of the big parts of AI regulation going on in the world is how drones will deal with emergency situations. Because you can have a person flying it, but if that person loses contact with the drone, then what is going to happen to the drone? So in the EU and Australia and stuff, now they have regulations where the drone has to then immediately land. But then that itself is dangerous. What if it just comes down on people? So then the drone has to not only be able to land, but also land safely. It has to know when it's coming down, it has to detect people. And if it sees people, it has to go and try and land somewhere else. if not, once again, it's just too dangerous to have these drone systems flying around all over the place. So once again, and those type of like emergency management systems can only be built with AI. So there is a lot of research going on how to build, especially at least emergency management systems into these drone systems. But then once again, the real challenge with these systems is always how to build this integrated system where you have a system which it works efficiently, but also works within the limitations of how a drone system should work. And that's my talk. So we'll discuss more. We'll talk about the production AI side during the panel discussion. Thank you.
Thank you, Ramesh. So I hope you got a flavor for, because Ramesh his talk was talking about the different components. And in fact, almost all the components that that we talk about when we say 4IR, you would have seen somewhere there, right? AI, the whole IoT area, and 5G and everything. So now we're going to look slightly at what happens with data. And so to do that, we invited Nuwan, and Nuwan will talk to you about some of the stuff he has done, and also maybe also I asked Ramesh to introduce himself, and he did kind of do that. But in terms of, why you're here and what are you doing here?
I find my slides. This is also visible. Okay, not the slides, right? Yeah. Afternoon, everyone. Can you all hear me clearly? Okay. And also, I think my camera is on. So afternoon to everyone joining us online. Sorry, I won't be able to look down on you because I'm looking at this audience. My name is Nuwan. My specialization is AI. Most of the AI that I've done, I did at Facebook, now Meta, where I worked on ads optimization, also things like fraud prevention and things like that. I moved back to Sri Lanka in 2018. I worked mostly in California. I worked in the UK as well. Now I'm doing some of my own startups. I'm also doing some consulting, and I also invest in a small scale on startups mostly in the AI field, but sometimes generally as well. Okay, so why did I decide to call this talk data? It's a very short title. So for most people, data is the world's most valuable resource. Dr. Ruwan mentioned his experience where you need to give the laptop, but not the data. Actually, it should have been the other way around. Like, no one should care about the laptop. The data is the real oil. And so unlike oil, data might not be a natural resource, but it definitely should be considered a national resource. So why is data so important? So we can talk about AI, machine learning, data analytics, all of these things. But none of that makes any sense without data. Data is the actual core. All the value comes from that. So here's some data about that data. This is the efficiency gains that we might expect from artificial intelligence. On the y-axis, you see the actual gains in absolute values in hundreds of billions of dollars. And on the x-axis, you see, okay, what is that share as a proportion to all data analytics? So one way of reading this is, okay, AI is actually like a subset of the value that you can get from data. The real important piece is data itself. So much so that I think of AI systems, and I'm kind of using the word AI a bit loosely here. You can replace machine learning or data analytics or data science for AI. Data is the most important piece. And often when we talk about AI, we sometimes tend to over-focus on things like the hardware and the software and the technology part of it. But data is the most important. For me, the second most important thing is the people who work with the data. And we need to invest in those people. And then comes hardware and software. So there's no point worrying too much about the mechanical parts of the system if you don't have any data and you don't worry about the people. Okay, so I'm going to start with talking about a source of data, which is not very glamorous. It's not something that we talk about a lot, but we should talk more about. And that source of data is what we call public data. So let me give you an example. So at the moment, I'm working with a medium-sized farm, basically. And they're trying to do some sort of apply technology to agriculture. And I'm doing some modeling for them around how to best use their sort of water resources. And they have some very interesting private data about their farm, the sources of water, and so on. But to do my analysis, I also need information like, okay, what is the rainfall? What is the temperature? The type of information that you might get from the Met Department. Now, there's a lot of meteorological data, which is actually public data. And if we can access that, we can make whatever we are doing with our private data, like AI applications, for example, a lot more efficient. So I like to think of this analogy now. All of us, we might have eaten different things for lunch today. We might have drunk different things. I drank water, you might have drunk coffee, someone else might have drunk tea. But we all breathe the same air, right? We eat different things, we drink different things, but we breathe the same air. Public data is a little bit like that. And from a public data point of view, the reason I'm talking about it is we are kind of suffocating because we have access to so little public data. And that is kind of the foundation for a lot of things that we can do with private data and so on. So I gave you the example of that project that I was working on. So public data has two types of problems that we need to solve. One is that it's not accessible. So there's a lot of public data, which as citizens, we have the right to see, but we don't see. So we need to make it accessible. So that's one. But once it's accessible, if we are to do smart, let's say data analytics or AI with it, we need to make it processable. Let me explain what I mean by that. So for that farm example that I gave, I got some data about our weather patterns. And if you go to the Met Department's website, every day, they publish a document with things like temperature, rainfall from all parts of the country, water catchment areas, and so on. Now, the problem with this, it's a PDF. And so if you're a human, you can go and read that the rainfall, let's say the maximum temperature in Anuradhapura is 33.1 degrees Celsius. Now, the problem is a computer looking at this doesn't see 33.1. The 3, the decimal point, and the 1 are stored in all kinds of different places. If you look at how this data is stored in a PDF, that's because the PDF doesn't store what the information means. It stores what the information looks like. Now, the problem is this is the curse of all data analysts because we need to turn this into something that can be understood by a machine. But both public and private institutions seem to love PDFs. Everything is published as a PDF, but from a data science point of view, it's a curse. So what I would do is I would take this and I would do some fairly sophisticated computer vision to turn that into something like this. This format is called JSON, which is very easy for a machine to understand. And now, of course, I have passed this data and I've shared it. So if anyone wants to use it, they can access it like this data. But it would have been much easier if the original source, that is the Met Department, publishes it in a way that machines can understand. So that's what we need to do. So I'm going to share some experiences in this talk, but I'm also going to share some kind of requests, like things that I would like to get done, which will help a lot of people. And so one thing I would start it is make public data accessible and processable. That itself, before we get to any fancy stuff, just doing this is going to make things a lot better across the board. And if you think about it, this is not just about AI. If you think of how state departments spend finances, that is public data. And imagine the amount of corruption that can be reduced if that data is shared publicly, right? So this is not just about technology, this goes way beyond technology, right? Okay, so let me change gears and talk about something slightly different. Now, so there's public data, and not all public data should be public. So for example, if you take health data, sensitive, it shouldn't be public. So this is a map of the National Health Service regions in England, and you get regions and sub-regions. And they have some pretty rigorous laws around how data is shared. So for example, some pieces of data can't even cross these boundaries. So for example, if you were in London and then there was another hospital in Manchester, you can't combine some of those data sets to build, let's say, like a common model. Now, the good thing there is the privacy of those patients, for example, is protected. But the bad thing is, like, if you wanted to build a model, combining data always gives you a better model. So let me take an example. Say you had some new cancer treatment and you wanted to build a model which tries and predicts how well a certain person would react to that cancer treatment. So you can build a model using the data from London, and you can build a model from using the data from Manchester. But if you combine the two, you get a better model. But with the current regulation system, you can't do that because the data can't cross boundaries. So one way this can be solved is to use something called federated learning, where essentially what you do is you build models at a local level, and then you combine them to get a global model. So the good thing there is you can't take the model and reverse engineer the data. So the patient, in this case, the patient's privacy is protected. So you can do this federation at different levels. So in his previous talk, Ramesh was talking about drones. Basically, you can have drones where each drone has its own local model, and then you can combine those to have a global model. Another common example is a phone. So Apple claims to protect users' privacy by building various local models on your phone, and it's combined to give a global model. That way, no private data leaves your phone. So that's the idea. Another area which might be maybe 5 to 10 years into the future, but I have a sort of a personal interest in this because I'm behind a startup that is working on this, is homomorphic encryption. So imagine that you all have some data, and you all have that data, and you all want to say build a machine learning model out of it, but you all don't have the expertise to do that. And so imagine I'm the expert in machine learning, and so you want to give me the data so that I can build a model. But imagine I'm not trustworthy, meaning I might take your data and run or sell it to your competitors. So what if you all can give me the data, but not in its raw form, but in encryption form, and I can build the model use on that encrypted data. I return the encrypted model and you decrypt it and you get your model. So that kind of sounds magical, like you're doing processing on encrypted data, but that is exactly what homomorphic encryption is. In this example, I give the simplest possible example, adding 2 numbers. So if you want to add 1 and 2, what you would do is you would homomorphically encrypt 1 and 2, and you get 2 numbers. You pass those 2 numbers to the untrusted data processor. And then that processor does an equivalent of addition, which takes those 2 numbers and you get another number, you decrypt it and you get 3. So this is the simplest possible kind of mathematical operation, but you can do any mathematical operation using homomorphic encryption, which in theory means you can run a sophisticated machine learning model, which in whole is a mathematical function using this. So this is still probably 5 to 10 years into the future, but the important thing to take away is not the mathematics, but the fact that you don't have to see the data to process it. So we can effectively separate the visibility or the accessibility of the data from processability. So this is huge because now privacy is no longer a problem because the person processing the data can't see what the data is. Okay, another important example is in banking. So, let me give you an example. In the last week, I was trying to file my taxes, and I was pulling various accounts from different banks, and I was looking at, okay, what are the interest rates? If we had open banking, and the banks had to share that data with, let's say, a third-party app with the user's permission. Then all of this tax statement generation can be done automatically, and then I won't have to do anything. Maybe just the IRD can access this data directly, and my tax statement is already done, right? So basically, there have been many examples where you create regulation where various institutions are forced to have open APIs, and like third parties can access the data, and that creates huge innovation. So one good example is probably the fintech ecosystem in Europe and the UK, where the moment these rules around open banking were created, there was a huge spurt in innovation. And that's something potentially we could do as well. So to kind of summarize my point there, we can make even private data processable by using some of these techniques, and we probably should do that. Okay, so let me move from data to people. I know, how many of you have seen the TV show, The IT Crowd? At least a few. Okay, so the IT crowd are basically IT department at a multinational company, somewhat shady multinational company. And the company, the headquarters occupy I think a 15-story building. The CEO has this penthouse suite at the top. The IT crowd occupy this basement, and they're in a corner of the basement. Right. So sadly, the many IT departments and data departments in companies in Sri Lanka and across the world are a bit like the IT crowd in that they are isolated. So they might not be physically in a basement, but they're isolated from the rest of the company. And the problem here is you can solve very little. You can't really solve sophisticated business problems using data unless there's a close coupling between the people doing the data and the people doing the business. So let me give you an example. So I worked on digital advertising, building optimization models for digital advertising. And not only had I to have a deep knowledge about machine learning and AI and things like that, I had to have a deep knowledge about digital advertising as well. You can't separate the two. You can't just be an expert in AI and try to solve the business problem. So similarly, I was working on payments fraud. And to build AI models to solve payments fraud, you have to get into the head of the fraudster. Essentially, you have to become a fraudster because otherwise you can't solve that problem. So as long as the data is separate from the other verticals, like in the IT crowd, this is not going to work. So what we need is something like this, where data is like a vertical, not a horizontal. Every department has data embedded into it, and you can solve that vertical's business problems using data in that way. And I'll kind of make a stronger claim. So we saw this graph about potential efficiency gains from AI. And I would argue that the areas where the potential of areas AI has been actually harvested have been in these areas where there's a close coupling between data and business. And the areas where we have not been able to get the benefits are where the coupling is broken. So I think in the future, this might even go advance more. So like 70, 100 years ago, no one actually typed. There were sort of professional typists, and if you want something typed, you had to go to them. These days, if you're like a billionaire businessman going in a private jet, you still do your own typing. So typing has essentially, everyone has to do their own typing, right? So I think in the future, we might actually have data smart verticals where this data role completely goes away and everyone is data literate, but we haven't got there. So before we get there, I think if we just do this, where we make data horizontal and data is embedded in every part of the department, then I think we are going to get some benefits from that. Okay, so keeping to the theme of people, it's difficult to talk about people and technology and not talk about the impact of automation on jobs. Right? So if you look at this, this is from some time ago about how automation will risk different jobs. So at the top, you get things like food preparation, construction, cleaning, driving, agricultural labor, garment manufacturing, very important to Sri Lanka. But you also have things like information technology and science and engineering somewhere in the middle, but even those which we think are kind of highly sophisticated types of employment will see like a 40% drop in the number of jobs. So you all know we have, I think, about 1 million Sri Lankans employed as 3-wheel drivers. Maybe in 10 years' time, we will have autonomous 3-wheelers. So what happens to those people, right? But there is another kind of transformation that's already happening, which is in jobs in information technology and engineering in particular, where automation has already got rid of a couple of jobs. So let me give an example of an experience that I'm having and some of my teams are having with a new AI product called GitHub Copilot. So for those who haven't heard about this, you can think of it kind of very simply as autocomplete for coders. So you're programming and GitHub Copilot will autocomplete. You write a bunch of lines of code and the Copilot will tell you what the next lines of code are. So it gives you suggestions and it also takes feedback. So you can say, no, this suggestion is bad. So it will correct based on that. So how this works is Copilot takes large amounts of public code and builds a model based on that to basically predict based on a bunch of lines of code what should come next. So it uses OpenAI's Codex model. You might have heard of AI model called GPT-3, stands for generative pre-trained transform-based model. The 3 is 3rd generation. This is sort of derived from that. Essentially, you could if you look at it from the outside, you can almost imagine that model is acquiring a sort of a conscious sense for language. So Copilot is in a sense acquiring a sense of what it means to write code. It's that sophisticated. So we had 2 types of experiences with this. One thing that we found out was for low quality software development. What I mean by that is where creativity is low. The Copilot was way better than what the software engineer produced. And so that job would go away. So the bad news is Sri Lanka, we still have quite a lot of jobs that fall into this group where essentially those roles don't produce any new intellectual property. We get requirement specs which tell exactly what needs to be done. And essentially what the programmer is doing is translating the requirement spec into code. There is no sort of creative input. So the good news is those jobs are going away, but the bad news is still there are many of those jobs and there's a long tail of software engineers that fall into that category. So the good news is that for high creativity software development, Copilot is actually a complement. So I kind of think of Copilot as a person with a lot of knowledge who has read every book in the library, has read every line of code that has been written, but is not very smart from a creative point of view. And so you need a human to add that creative piece. So it's kind of ironic that the way things are, our education system is heavily biased towards knowledge versus creativity. Like creativity is not something that's tested. Knowledge is something that is a big part of it. So in a strange way, we are not producing humans, we are producing people like GitHub Copilot, which is not what we need. So there is irony there. So there's actually a word for this where high creativity individuals are enhanced by technology, and that's called informating. And you can think of it as the opposite of automating. Automating, the human is replaced. Informating, the human is enhanced. And this is actually a 2-way problem. We need to both develop technology, which does the informating, but we also need to develop humans to complement that. Okay, so that's all I had on people. I wasn't going to speak a lot about hardware and software, but I have a couple of things to say about it, which are sort of topical given today's kind of world situation. So we all had serious issues with energy, fuel shortages, and so on, and we still have power cuts. That's something to really worry about, because going forward, to do AI well, you need large amounts of power, and so we need to figure out, okay, where is that power going to come from? So no power, no AI. Even in many developed countries, power can be the bottleneck, where you can't do AI because you can't afford the power cost. So that's kind of one thing to think about. I'm not sure what our solution is. Like there is no, it's not a problem that an individual or a company can solve. This actually goes beyond the country. The other interesting development, which is like even newer, is kind of world politics, which is now in the past, and past is very recently. A year ago, if you wanted to buy a chip from someone, you could just buy it if you could afford it. And the same applied, okay, if you wanted to get an account on AWS or Tencent or whatever it is that you're using for your infrastructure, you could pay for it and get it. But now technology is getting political in that certain countries are saying, so certain people from other countries can't buy their software. So already now there is a China-US kind of competition where technology has become part of politics. And you have some interesting people who are watching this. So now China and the US are publicly fighting, but you have people like India who are kind of neutral. They are seeing which way this is going to go. They might even form their own bloc. Brazil is another really interesting example of where now they have a new head of state, and they're also watching this chip war to see, okay, which way is this going to go? Should we support one side? Should we support the other side? Like where do we stand? So this is also kind of interesting. And again, it's a question that we need to be aware of. We might not be able to influence this, but we will definitely be affected by them. So these might be things that we can't solve. I'll end with quickly summarizing the things that we can solve. So making public data accessible, that is something that we should definitely try to do. Public data is like air, and we are suffocating at the moment, right? That's the reality. The other thing to think about is even private data can be made processable if we do it the right way, and we should try to do that. We should have open banking APIs. We should have regulation which enables combining machine learning models and so on. We should really think smartly about private data, getting the right balance between privacy and processing. Number 3, we shouldn't build companies like the IT crowd. At the moment, data is siloed. We need to make data horizontal. So that's another thing we should do. And finally, we need to informate. So we need to do 2 things. We need to find out how machines can complement humans. And we also need to figure out how humans can be less like machines and more human. Right? That's all I had. Thank you very much.
I think that would be another.
Framework, I think such kind of lawsuits would not come up. So I think there should be that block in your diagram.
Left out a bunch of things which I might have included. One is like legal analysis. Another thing is like fire caused by data and things like that, problems caused by AI systems. But I left it out because I think initially we need to focus on getting something up. So these are problems that I think we can think about once we have like a few $1 billion revenue from AI. And we should focus on first getting something on the board, and then we can think of the issue. It's a bit like thinking about vehicle pollution when you don't have any cars. If you don't have any cars on the road, vehicle pollution is not a problem. So once you have some cars on the road, then you can think about vehicle pollution. That's why I kind of let those topics out. Very important, but I don't think they're there.
Thank you for starting the discussion even before. Yeah, I think the food makes it happen. I think, and it's a good thing. I think. Just one thing. I think because Nuwan has he just mentioned that some of these data he did the hard work and got them out, and it's available, and all his stuff is publicly there. All the public data is publicly there, and one of the things. And he constantly tweets about these things. And one of the things some months ago was when he put this thing with the train data. which showed, for instance, that the Kalani Valley line is underutilized or something like that, you know. So these are not just just nice graphics, but these are things that can inform us to make decisions. Okay, let me yeah. So I'm happy that that you. I'm happy that the audience here got to eat, but those who are online, we still don't have the technology to send out the drone with the tea because of the regulation, as Ramesh said. Yeah, right. So I didn't intend to talk. Actually, I intended to moderate, but one of our committee members, Professor Priyanda, said, no, you have to say something. And so I just, so I want to talk about the area that I work in, and Surangika here, who just asked the question, also works in that area. And some others, like I suppose Mudita and some others here. So my talk is not very glamorous and with all these pictures. It's all text. It's because I'm talking about language, and language is represented here only with text. So what is the importance of language? Before that, I think both speakers before this talked about the central role of AI in this whole fourth industrial revolution. And within AI, this is a term, as Ramesh said, this is the term that was coined in 1956, so it's a long time ago. And it was, concerned with problems like search and knowledge representation and reasoning and things like this. And then people felt that, we can't solve this big problem. The Romantic era was where people said, we had this 2001 Space Odyssey where, the people talked to this computer and all that. They abandoned all that and they said, no, we need to actually do something and show some results. And so we had some showcase applications like expert systems and all that did little tasks. Until one of the main components or pillars that is learning came and was able to fill the position that none of the others were able to. And so today, AI, why AI is the cornerstone of the fourth industrial revolution, within AI, machine learning is like the core. Right. So that's why some people say, no, he's doing machine learning or whatever. No, I'm doing AI. And I think, oh, what's that? So it's very confusing, all these terms. And so some people when they refer to AI, they mean like chatbots, where you can talk. I think it is coming from hell and all those things, it's a computer you can talk to, right? But these one of the things in machine learning is also called learning human language. And traditionally, this has been seen as it used to be seen as the holy grail. This is what we need to solve in order to get computers to understand us. And so these are normally done through what are called language models. Now, what are these language models? Well, computing people, as Nuan said, we have to go to the subject matter expert, right? The domain expert. The domain expert is a linguist. And so the linguist told us this is the way language works, right? We have these rules, and then we learn these rules as children. Well, we don't really learn these rules as children. We learn these rules as adults if you want to learn another language, right? And then people got a bit, these people are a bit dissatisfied with this, and so they said, this creates a lot of ambiguity, and we need to incorporate some probabilities, right? So we started having these statistical language models in the 1990s, for instance. And then computing people came and said, well, actually, we have some great learning algorithms in machine learning. Only thing they need numbers, they need numerics. So the big jump was, how can we represent text as numbers, as vectors? And so that happened again, in a turn of the millennium. And then we extended these things to what are called embeddings through a deep neural net training. And a particular deep learning architecture which came to dominate kind of this area, which is called a transformer. And Nuwan talked about probably the most famous of such transformers is the GPT. So initially these were applied to language, but now extended to other areas as well. So what can these language models do? Well, initially those prescriptive grammars, the linguists, they were very brittle. And so the language model was supposed to say whether something was grammatical or not. It's like a binary, 0, 1. And in our schools, we still have that model, right? So if you make a small mistake, then your teacher will ridicule you, and that's the end of it. But language, when we interact with people on the street, or when we go to a conference, we meet people from other nationalities who are not so, uptight about this. We know that it's not a binary decision, right? There is a probability. It's a probability distribution. So some people we can understand like 100%, some 80%, some 50%, or some sentences. Right. So if somebody says, you go, I come, hotel or something, we know what that means, right? It's not 0, nor is it 1, but it's some probability in between. So the statistical models help us to think about that, right? So instead of having rules, they said, let's give probabilities to sentences. So this sentence looks really good. This one is not so good, but maybe we can still understand. So what did they achieve? Well, initially they achieved what is called next word prediction. No big deal, but you could predict the next word, right? Humans also could, right? Humans, if you ask humans, they can do it. So these models were starting to do that. And then we went to other tasks like masked word prediction and so on. And I'm not going to bore you with all that stuff. And then using that to solve some problems. So not just next word and masked word, but maybe sentences and paragraphs and things like that. And also other useful tasks, like to categorize documents or to detect sentiments or to make summaries and translations and so on. And so now we have a battery of tasks, right, that we apply these models to see how good they are. So initially it was for translation, we had a thing called the blur score, and that just said how good your translation was with respect to some reference translations. But after that, they said, we need to have a whole battery of tasks to see how good a language model is. So here's one example, a common example. So initially we couldn't do this kind of thing. The summaries used to be just the most informative sentences. So you have a 10-sentence document. You say, give me the most informative 2 sentences. That's called extractive summary. But this is a abstractive summary. This is like what we do in school, right? In school, we are supposed to do this, and we are not supposed to take sentences from the document, from the article, right? So this now the state of the art is here. I can do this. Can do this kind of thing. This is a question answering, but actually this particular one also has some, within quotes, common sense. What is your favorite animal? Why? Right. That's a bit of a difficult question to answer, right? Even to humans, right? So this is a real dialogue. So all these I've taken real examples from the transformer model that Nuwan talked about, GPT-3. This is a poetry. So the convention in this when talking about this is to have the so-called prompt or the stuff that the human gives in bold, and what the machine produces in normal body text. So you can see this is just by giving those first few lines, the machine is completing this Shakespeare piece. This is another one. This is actually a blog, right? And if you read this, this looks very much like a description of GPT-3. But actually it was generated by this prompt, the prompt that is in that box, right? So I share my early experiences with OpenAI's new language prediction model, blah, blah, that's all. And then the rest of the blog was written by GPT-3. That is this part. Right? Interview. Okay, so this is another kind of, people come up with strange use cases. Nobody thought that we want to interview Albert Einstein, right? But this is an interview with Albert Einstein. And of course, when you connect this with deep fakes, the results are like stunning, right? So this is the prompt for that. Right? So this guy wrote this as a prompt. And then the rest of the, I'm not actually wanting you to read the whole thing. I just, the rest of it is that interview, right? So all the prompts are given in bold, and the response of the system is given unbolded, right? So you may be interested to look, but there are lots of these things, right? So paraphrasing, simplifying, detoxing, right? So there is like, now there's a big concern about on social media, people are, they're speaking in tones that they normally won't if they are face to face. So somebody said, okay, let's see whether we can use GPT-3 and detox the things that somebody says. Emotion detection, program writing programs in different languages, interpreting programs that are written in languages, identifying document layout, UI screen, those are not so clear, but captioning photographs, right? You have photographs. So now this is where it goes beyond just language, but also vision that Ramesh was talking about. Describing video. I think some of you may have seen DALL-E, I think, from Google. And now that's text to art, right? So you describe something and the system draws it, comes up with an art. And that list is endless. I mean, people are doing crazy things with it. Right. So people said that, okay, so we need to have a high bar. And so they built this thing called Beyond the Imitation Game. Beyond the Imitation Game is big bench suite of tasks, 204 tasks. These are just the big bench light, right? These tasks on which your language model will be tested. And now this has become, I mean, the 204 tasks, still systems are not doing very well on those, right? Very low scores. But the idea is that you should be able to do these. And if you look at some of these, and if you look at some of the other things, the scope is very, very large. It's, things that may pass the Turing test, right? In fact, there's now the favorite pastime has become of these people, rumors, GPT-4 rumors. What's GPT-4 going to have, right? And so they're saying it's orders of more dimension of parameters. That's not such good news for people, but less power consumption. That's really good news, even with more parameters. And then able to process images, audio, video, and so on, in addition to text. Right. So these things, generative models started, I said, with text. Right. So, but possible for whom? So I want to pick up what Nuwan was saying. Possible. I mean, all this is possible, and all this is possible, but possible for whom? Which people groups will be served? That is one side, right? And so, and the second side is which organizations would thrive, like would benefit, would profit. Right. So Thomas Friedman famously wrote a book, The World is Flat. The world is flat in terms of, because of technology. I mean, by and large, everybody says all you need is a laptop, right? And then you are, equal with everybody else. Not quite, as Romesh also said, not quite, right? But in fact, somebody said, I think our friend Sanjeev said the world is not flat. It's tilted toward our side. What he meant there was that, some of these other countries have legacy systems, like the phone system legacy. We didn't have that, so we could jump into, I don't know, GSM and so on, right? So, so how do we identify areas of research in which we have actually a level playing field, and then so that we don't kind of waste a lot of time on other areas? So yeah, this is not okay. You see it a bit better than me. So this is the graph. If you look at this is actually 2 years, January 2019 to January 2021. And the size of the sphere is the number of parameters of the model. And the size of those squares is the size of the data set used to generate these models, right? In the good old days, it was thought that if the number of parameters exceeds the number of data, then of course, there's something wrong with your model, right? But it turns out that these models are able to generalize from those data sets. And so the biggest circle there is not GPT-3. So there are bigger models than GPT-3 now, right? And the number of parameters, those of you who are, we have this parameter, y equals mx plus c has 2 parameters, right? And then if the curve is a bit more complicated, 3, 4 parameters, right? So this GPT-3 has 175 billion parameters or something. And this one on top here has, I think one of them has 1.6 trillion parameters, like mind-boggling, right? So what does this mean? There's a big cost, right? Economic as well as environmental, right? The average human is responsible for about 5 tons of carbon dioxide emissions per year. A single transformer model training procedure results in 284 tons, right? And these 2 graphs, this chart and the table below show the kind of cost that results in monetary terms, in dollars. And you see this ends in January 2019, where the other one started, right? So this is at the beginning of that. And that model has 213 million parameters. Okay, but except that was optimized using, to find the best parameter set, they used what is called neural architecture search. So that is what made that have such a huge carbon footprint. So the amount of compute needed for these largest models has increased 300-fold, 300,000-fold. And that means in 6 years, and that means it's going much faster than the Moore's law. The thing is, and this is the really bad news in terms of for us. Some of these abilities are emergent abilities of these language models. So as they become bigger, at some point, suddenly they are able to do something. So those benchmarks don't score very well. And then suddenly at some point, I don't know, so many billion parameters, they start picking up. That's actually bad news for us, right? But everybody's excited about it because they are suddenly starting to solve problems that we thought were never solvable. Right, so the data sources needed, the size, okay, so these are very important things. Size and diversity are not related, right? So you need a diverse set if you want. So the example that Nuan said, like if you have only one set of data from which to learn, you won't have such a good model, right? But, and that is related to diversity. So if you have the same kind of data many times, then in fact, your model will not learn so well, right? So these big, huge data sets are created a lot with Wikipedia, Reddit, and social media, right? Sometimes filtered using keywords. I mean, some of these filtering schemes are fairly, what shall I say, unmotivated or not very well motivated, right? So what gets filtered out is unclear, right? It's not very well documented also. And this bias serves certain segments, right? So you have the best models are for British and American English, right? And then French, German, and so on, and then the other languages at the end. And then demographically, 67% of Reddit users are men, and 64% are between 18 and 29, right? So we are fossils, right? So and dramatic content gets more bandwidth usually, right? In user-generated content. And as I said, no good documentation exists for you having to declare the data sources. And so some people are working on this kind of thing for ethical use of these, right? To improve this. And of course, very famously in February 2021, Google fired their lead ethicist, AI ethicist, right? Timnit Gebru, and for raising some of these issues. Right, so the research frontier has moved, as I think both the speakers mentioned or alluded to, from universities to companies, right? So now, companies have many more PhDs than universities, or universities put together also. And so this has resulted in actually an acceleration in AI research. And so that's positive and negative. No? The negative thing is it's harder for ethics and the law to keep pace, or regulations or anything to keep pace. Already they were behind, but now because of this rapid pace, they are way behind. And so arguably this results in a focus of shift. Some people may disagree. So the People and Planet part is going back a little bit compared to profit, because these profits are humongous. There are, of course, OpenAI and Allen Institute. These things are meant to be public, and that's why GPT-3 and so on are public, right? And that was one of their goals, to make. So since we can't run those models, we can't train those models, they want to train the models and give us those pre-trained models so that we can use them. Only thing is, most of those are English. Well, some people are also doing it for other languages, but much slower, partly because we don't have large enough data sets, diverse enough data sets for that. And so in some ways, these have a bearing on the entire research direction, right? Without us knowing, this has happened, right? So the focus has changed. Of course, people can say that the earlier research was not really universities, but they were military, because most of them were funded by DARPA, right, in the US. Okay, so some implications. Large language model, LLM means large language models are able to mimic or even surpass human level performance on some tasks. These are the so-called system one tasks. I'm not sure whether you are aware of the system one thinking, system two thinking, right? System one thinking are things that we do very quickly, instinctively, but we may sometimes get wrong. System two tasks are things that require, time from us also. We have to think, do some deduction and so on, right? And progress on those is not good, even if with these large language models. But AI is moving from single task learning to multitask learning. That's like a very hot area, right? And this was demonstrated initially. I think everybody's attention was caught up by DeepMind's AlphaZero, right? For two-person games, it showed how something that was trained on one game could learn another game and still excel in that to be the best in the world, right? And now they have gone a bit further. DeepMind, they have something called AlphaFold. So yeah, maybe Ramesh is interested in this, right? Protein folding, which is a hard problem, right? And so I haven't read about this enough to know whether alpha is just the label or whether actually it is carrying from the game playing domain something, right? But if so, then that's like really, that means, so the hot area is transfer learning, right? How far does transfer learning work? Usually it's into related problems, right? But of course, two-person games and protein folding are completely different. So how do they do that? And large language models also showing abilities of going beyond a single task. Earlier we trained them for either, I don't know, classification or some particular task, sentiment detection or something. But now these large language models are doing all these things, right? So the rate of progress in AI technology appears to be accelerating, which is why people are talking now about the so-called technology singularity, right? And people like Elon Musk think that, I don't know, it's going to come in 2000 and whatever, right? That brings me to that thing that, an anecdote, but I think I don't have time. Let me just conclude with this slide. So we are moving from this narrow AI to this thing called artificial general intelligence. And some people are not happy just being there. They want artificial super intelligence, right? So not trying to be like human, but to far exceed humans. And that's where this whole singularity thing comes in. So to be competitive and stay relevant, we need obviously to identify niches. And this is, commonly we say this. But two things. One is to bring dividends to our people. But the other is to compete globally. And these two are, I think, two things we should try to hold together, right? Some people only look at our situation, and others only look at competing globally. So for our research, for that, this leads in these two directions. So contextualizing technology application, and that's why, for example, with language, that means, can we do this stuff for Sinhala and Tamil? But not just for language, for other things also. How do we contextualize so that our people benefit? I think people like Hiranya, working in government for that. Right? How do we make them also reap the benefits of technology? And the other is, of course, we are very bad at recognizing our own our own manpower. So this example I've given is the fingerprint identification is one application, but there are lots of applications like this that functions, that's very good, but which our governments don't want to implement and use. And if they use it, they are not just giving somebody some money, they're giving reference implementation so that our companies can go to another country. Because anywhere you go, they want to see where is, where is this working, right? If it's not working in your own country, then what can you say, right? So this is another area, I think, when we come during our discussion, maybe to talk. And I think there are lots of areas like that. And so the mindset that foreign is better needs to be dismantled. And I see that this is a far bigger challenge going forward than technology. Okay, thank you. And yes, we will, as I said, three of us wanted to just throw out these things, but what we really want is to see how we can, in some way, help not just NSF, but government, through NSF government, to support. In what way to support, right? We have all, I think, looked at to support in terms of promote as well as to be aware, and that was a very good question answer that we had just now. That whole issue of sometimes countries leapfrogging and then putting the rules on the other countries, right? So we have to be aware of that also, right? So can I ask Nuan and Romesh and Ranil to come up, and then this looks a bit far, but hopefully we'll be able to have a good Q&A. And we have here some questions already online, which will be asked. I think you will need a microphone to ask those. We have a microphone in the audience, right? Yes. Yeah. And from time to time, let's pass it to her so that she can ask. Can we just check whether this is working? Okay, so let me also encourage those of you who have joined us online to ask questions through the chat, I believe, because we don't have a microphone near the machine that is connected. Okay.
Hi, I'm Noeline Prince from University of Ruhuna. My specialty is applying machine learning algorithms to neurological data. So thank you for all the presenters. Just following up from the last question and Dr. Ruan Veerasinghe's presentation talking about ethical aspects of AI. This is also another area that I'm involved in. So last week I presented about the ethical, legal, and social aspects of cochlear implants. They have lasted since the 1700s, but because there were no ethicists at the beginning involved in these things, even in 2022, we don't have an ethical framework to talk about the cochlear implants. So it has taken more than a century and we are still talking about it. So to that last question, I want to say we shouldn't wait till we have pollution to talk about pollution. We need to start talking about it at the design stage. We have to think about what are the ethical, social, cultural, economical, all aspects. So that was a comment, and my question, I guess, for discussion is going from Dr. Ruan's last point. Everything that we import from the West is not the best. So in Sri Lanka, how do we handle this? We know that there are lots and lots of specialists in Sri Lanka. We have a lot of companies involved with AI. How do we tackle this problem? How do we not repeat the mistakes that the West has done? But also, how do we not limit our developments by regulations that they are putting? How do we come up with our own system to address this? Thank you.
Have a go. You want to have a go? It's actually. It's actually.
What can we do within Sri Lanka?
Your question was pretty broad, so I don't want to answer the whole question. But let me make some comments on that. I think the phrase West is best might be a bit of a simplification in this case, because if you take AI research, it's coming from all over the world. China is a good example. I think there's a significant amount of AI advances happening there. India is another good example. So it's a little more complicated than kind of phrasing it as just the opposite of West is best or something like that. So that's one comment. The other comment is we should be careful about kind of confusing the information that we have with retrospection. So we don't really know in what direction technology is heading. So we shouldn't be kind of too quick to kind of jump the gun and legislate for something that we don't completely understand. So kind of going back to the example of the analogy that I gave with pollution, it's almost like in Sri Lanka, given that the state of AI development is somewhat behind, but not only is it behind, it might evolve in a different way. So we might end up with to take the vehicle analogy, we might end up with a vehicle which is nothing like the vehicles that are in the West. So because of that, we shouldn't kind of jump the gun to kind of legislate something that we don't quite understand. So I'm kind of a little conflicted here, because if I look at it from a world point of view, I think that we definitely need a lot more kind of ethics and like legal frameworks, because to me the state of AI in the developed world is a bit like a young adult, and now that young adult needs to know how to behave in the world. But in the situation in Sri Lanka is like an infant who hasn't learned to walk, and we need to be careful not to shoot the baby before it can even walk. So that's my concern.
I would also like to chip in with a quick question, which I want to address to Dr. Ranaman. We talked about the necessity of regulation for drones, for unmanned aerial vehicles. Well, that simply opens the door to a lot of other kinds of vehicles, which will also in the future be unmanned. And we already know that in many countries, vehicles, cars, are now driverless. It hasn't happened to Sri Lanka yet, but it is happening in other countries. And some problems have cropped up with the driverless vehicles, including, of course, legal questions about who is responsible in the event of accidents. And my understanding, I'm no expert, but my understanding is that eventually, not just cars and trucks, but even ships and trains and passenger aircraft may be autonomous, right? How do you think this would affect Sri Lanka? What should Sri Lanka be looking at in terms of regulation? Should we be regulating to restrict these things from happening in Sri Lanka, or should we be preparing for them happening in the near future?
I mean, that's a really relevant question. And I know Singapore has set a goal where by 2030, they don't want to have any driven taxis by 2030. So it's a very ambitious goal. It's only in 10 years' time. And Singapore is a country which has something like 45,000 taxi drivers. And they're all, it's even more complicated in Singapore because there are no foreign workers who are taxi drivers in Singapore. By law, only Singaporeans are allowed to be taxi drivers. So they're going to have 40,000 people who are unemployed by that time. So I certainly don't think that we can stop progress. This is going to come. So then the question is, what are these people going to do? What are going to be the implications? And that's why a national policy on this, where we are not caught. I mean, the big problem that Sri Lanka has is that our economy is still heavily dependent on manual labor based exports, and that if you look at other countries, it's developing countries who have a very large proportion of their foreign revenue dependent on these manual labor based tasks. And if those so that means we have a lot of people who are working on these lower skilled type of jobs who their families, their livelihood depends on this. So the question is, if we don't have a policy, we are going to be caught, with literally with our pants down if this happens, because the sectors which are heavily dependent on people, like the apparel sector, they have no choice but to automate because they're losing the competitiveness with other markets. They have no choice but to automate. So we won't even know when suddenly we'll find that in 2 years, 50% of all the apparel factories have been automated and 50% of the staff have lost this thing. So this is exactly why this has to be led on a national level. We can't stop the automation, but then on a national level, we have to drive exactly what's going to happen to these people when this comes down. So definitely setting up that, having a national policy on that, I think is a really important. And thing is, even more so for countries like us, where more of our foreign revenue is dependent on these people, and if they lose their jobs, then it's going to create a huge social problem going forward.
We have a similar question in that line. It's Lalita Lienage. Although we believe that we have one of the most educated populations, about 50% of our labor force have not completed O-level, and only about 8% of students entering grade 1 gain access to state universities. This means a large portion of our labor force is occupying jobs driving garment and food industry. Most AI aims to replace these jobs with machines, which means such people will not have employment, and there is no way to increase the intelligence such a large portion of the population. This will create a population of people with psychological and social problems, which would be toxic to the society. Therefore, should there not be regulations to not replace such jobs with machines, at least for Sri Lanka?
Shall I answer that? Yep. So that's a huge discussion that's going on around the world at the moment. But my personal feeling is that's not a right direction to go in. We've had this type of scares coming up with so many different technologies. Just recently, the same stories are going around about digitization, where the more digitization happens, more and more people will lose their jobs. But what really happened was, through digitization, new jobs were created. There were much more jobs created after digitization than before digitization. And it's going to be the same with artificial intelligence and machine learning and automation and all that. some of the traditional jobs will be replaced, but that will also create a whole host of new jobs. So the question is, who are going to be doing those new jobs is the main question. And envisioning those new jobs and creating those skills to fill those vacancies is our thing. But I don't think we as a country can hold back progress, because that's only going to make us less competitive in the world. That will drop our foreign revenue, that will make our people less competitive going for jobs, what our companies can do. So really, it's a matter of perception and education, where this automation AI is being used a lot to create fear among staff, even in the companies I work with. The moment we say we are starting an AI program, what comes into their mind is we are going to lose our jobs. That is never the case, and I've never seen that happen. What happens is when we bring in these AI-based solutions, it helps these people do their jobs better. It makes it more efficient. But still, at least in the companies I work with, we've never had to replace people with an automated system. That's never ever happened. It just helps them do their job better. And that's a matter of education, how we pitch it as well. So even in the corporate sector, when you're talking about a transformation ladder, it's very, very important to educate those people within the company on what the true impact is, and look forward from there onwards.
Yes, please. Is there a mic there?
Okay, shall I ask my question? Not a question, so then I can pass it. So just to continue the discussion on AI, the ethics and legal framework requirement. So the fact that we are in Sri Lanka doesn't mean, I think we should not think that we are infants, because we are working in a global environment. So I'll just give a few personal experiences I had. So one is, so we created a data set that has text has been annotated with hate speech. So we submitted a paper, and one reviewer asked, are you going to release this data set? Because you should not be, what will happen if some bad guy use this data set to train a model to generate hate speech? It was something that we never thought of. So as a person who works in the area, I would say a researcher, I should be familiar with these, frameworks, at least those that are governed by my university. And then other examples. So I'm currently working with some set of international researchers to generate a data set which involves information from minors. So those researchers say, now you have to get ethical approval for this project from your university. Luckily, my university, University of Moroto, has recently established a committee to give ethical approval to this kind of research. So I could keep my head up and go and say, okay, I could get the ethical approval. So if it was not there, so it means that we are far behind the rest of the world. So that is in the perspective of someone working in the area, the IT guy. And I would like to share another experience in the user perspective. So Dr. Ruan mentioned about the text to images. So recently my son wrote a book, and since he doesn't like to draw, what I did was I used an AI art system, text to art system, to generate the artwork for the book. Very nice, marvelous. So I put it. And then I got an ISBN, and then I wanted to put the statement, all rights reserved, with my son's name. Then I started thinking, can I have the right to this book when the art was generated by an AI art system? I didn't know. So then I read through, I used this system called DAL-E. I read their guidelines. I wasn't clear. Then I raised this question in Twitter forums, and people say it's still a gray area. DAL-E says you can use, but people are saying, others are saying DAL-E should not be doing this. So it's not ethical, because DAL-E is using images drawn by other artists who are still living to produce new artwork, which will put the artist into trouble. So now as a user, I should have this notion of ethical and legal aspects of using the outputs of AI systems so that I can use it in my work. So because of that, we should not think that we are not we are still not yet there, but we are there. We are facing the implications of not having legal and ethical frameworks in our country. So because of that, I think we should really start thinking about it. And then I would like to share some information. Actually, I don't have a question. So I work in the area of natural language processing. So recently a colleague and I carried out a research. My colleague, Dr. Nissan De Silva, he has a live paper. That means a survey paper that keeps on updated. So this is on the NLP work that has been done on Sinhala language. So it has all the papers people have ever published on Sinhala NLP. So what we did was we went through all the papers cited in this research paper. We wanted to identify how much impact that has been made by the research reported in this, in this survey. So what we found out was only 11.43% papers has data set publicly released. So they say they create data, they don't release, right? And then out of that, on about 10% are in personal repositories and only 1% is in public repositories. So this has a huge impact on our language, because recently there was another study by some Indian researchers which classified the languages based on the data availability in public resources, repositories. And because Sinhala doesn't have any data, Sinhala goes as an extremely low resource language, which is not correct at all. And then based on our analysis, we found out only 9.7% papers have released their code publicly. And only 5% have released the tools that they have claimed to be. So this is the status of the natural language processing research in our country. I believe this is the same for other areas like machine learning in this wide spectrum of AI. And then if you look at the pair where we publish the papers, our research, so it's mainly in regional IEEE conferences. So in NLP, we know that there's this ACL research, the conferences, a negligible amount of papers go there. So this has two implications. One is our research does not get noticed by the top end people who are referring to these proceedings of these high-end conferences. On the other hand, it may also imply that we are not doing state-of-the-art research that could penetrate into these high-end conferences. So that's a two-way problem, right? So we have, if we are going to do something about this industrial revolution, the fourth phase, whatever, we have to think of all these implications, doing cutting edge research and releasing our data, not only data, our software and our tools that we build. So no question, just some points that I wanted to share. Thank you.
Thank you.
Just let me add, I know we keep saying ethical and legal. Don't forget to add the social and cultural aspects to it as well. Thank you.
By the way, we are taking all notes down. Yeah. Yeah.
Hello, I'm Menaka from Open University. This is regarding that we have taken tremendous steps to popularize AI in the university culture. So now it is being established and so on and so forth. But when we take the school education, at least very least has been done in the school education, at least to popularize, educate, and the other aspects. And in the West and in the other countries, they have taken not only the popularization and the education, but they have taken steps to establish systems and other things to enhance and engage the students, and so many other aspects being integrated into formal education systems where we need to build up the next generation. So I would like to know whether we have in a position or we are in the right steps, whether we are going to inculcate those aspects into our education. And I have another question that when we, with Dr. Ramesh first figure where the robot with the actuators and the knowledge representation and all of these things, how we can think of integrating the creativity. Because when it comes to a robot, not even a 3-year-old child's aspects cannot be done yet. So it's not up to that stage. So in that aspects, the general intelligence and all these things needs to come, and the knowledge representation and cognitive artificial intelligence, all these aspects needs to come. So any kind of directions on how to do get these things done? Thank you.
Yeah, that's a really good question, Dr. Monica. I mean, the big problem, in my opinion, at least that I see in Sri Lanka, is that a lot of the efforts within the AI area are very segmented. You have lots of groups who are doing a lot of things, which is very impressive because they do it with very little support from anybody else. But it's not a coordinated effort. I mean, a good example for that is there is this amazing program in Singapore called AI Singapore. And it was set up by the Singaporean government about 5 years ago. Singapore at that time, their global ranking in AI readiness was something in the 40s. But now if you go into the AI readiness index today, they are number 2 in the world. And what this program does is it attacks the capacity and ability of Singapore on AI on all levels. So on one side, they have created national level content, and they specialized content for primary school children, secondary school children, university students, corporate leaders, chief executives, lecturers. They have created about 300-400 different courses. Most of them are free, some of them are paid. Then within that itself, it's a program with about 5 different pillars. Then the next one is they have a program called the 100 Experiments Program. And what they're doing is they're running this with the National University of Singapore. And what they do is they go out into the Singaporean community and say, what are the AI problems that you have? Is there something that you want to do with AI? Then they have a filtering process and they select some projects. And then when they select a project, what they do is from the Singaporean community, they hire what are called apprentices. And these apprentices then work on this project for either 9 months or 18 months with a team from NUS. So for that 9 months or 18 months, they have to leave their job and they join this AI Singapore program, and they are taught how to take an AI project all the way from conception, design, all the way to production. And it goes out, and then that system is handed over to whatever that entity. It could be a corporate entity like a bank, or it could be a social enterprise or whatever. But then the greater thing is that those people then go out into the community and they are experienced engineers in machine learning. Then they have a funding program, and that's also within AI. They have their own maker spaces. So it is basically a national level initiative which is focusing totally on AI. It's not spread around, different things. It's just totally focused on AI. And this is why Singapore now is number 2 in the world in AI capacity. And I think, and it is by creating that multi-spectrum access and awareness of AI that you can bring in that aspect of creativity and all these other things. If not, it's very transactional. You're looking to solve one problem and you look at AI only from that angle. And it's only by digging that full 360 view that I feel. And I think even for Sri Lanka, that Singaporean program, I think, is a benchmark for us on how, a small country like that with 3 million people have now gone to number 2 in the world in AI. And it's totally with this very, very directed program that they run within the country.
I would like to ask a general question, and I'm asking it from actually all 3 of my fellow panelists, but I would also invite anyone in the audience to jump in with suggestions. So at the end of the day, we have to come up with a way forward. And I think something very interesting was just suggested by Dr. Ranamana. In general, the examples given, I think the very fact of the distribution of expertise here, as well as the data mentioned about the number of PhDs working for Google, suggests that the cutting edge of AI is not in the universities, but in the private sector. But we are here in the NSF, and the NSF, one of its functions, of course, is to fund research. And my question would be, what initiatives can we suggest that could be implemented by the NSF, whether in terms of funding research in specific areas of AI or in a more broader activity such as the one described in Singapore? Are there any such initiatives that we could propose to the NSF as well as to the government of Sri Lanka? And if the proposal involves funding particular areas of AI, what should those areas be? I can see many hands raised in the audience, so let's take the answers from there before I turn it over to the panel. Yes, sir.
Very interesting and informative session, I would say, very interesting. So, my name is I'm from the research perspective. Now, people mentioned that in Malaysia and other countries, they have a lot of AI tools getting research. Right? Do we have any plans of, not really bringing those here, but some sort of, those tools helping Sri Lankan businesses to improve their processes, improve ROIs using AI, please?
Yeah, I can. Okay, I'll answer that. So the big problem with AI is that AI technology is fundamentally different to other types of technology. Any other type of technology, software systems, robots and all, you can very simply develop it in another country and take it to another country, and it all depends on how you use it. But the inherent problem with machine learning based systems especially is that these systems, their performance and the output and the value you get from them is dependent on the data that it was trained on. So really, if it's a system that's developed in the US, trained on US data, or Malaysia trained on Malaysian data, it is very difficult to relate that to what happens in Sri Lanka. So which is why, even though we have software and technology from all around the world in Sri Lanka now, we don't have many AI solutions which are running in Sri Lanka, because for it to work in Sri Lanka, it's got to be trained on Sri Lankan data. And that's the inherent problem here. And that is why we are behind in the world, because our normal operation, even the private sector companies in Sri Lanka, the moment they have a problem, they go and buy something from India or Singapore or the US, they implement here and it works from the next day onwards. But with AI systems, that doesn't happen. You still got to train it, build it on our data. And for that, you have to have the engineers who know how to collect the data, prepare the data, train the models, and that's our inherent problem. So that's one side on solving social problems and all that, which is why we are not seeing these things. But on the other hand, to answer your question on these tools for optimization in terms of companies, the way we run companies are very similar to how our companies are run in Singapore. Those tools are now widely available on all these different platforms like AWS, Google Cloud Platform. Now, at the moment, I'm running the AI program for the Asiata group. And we have, basically, I'm setting up a single blueprint for the entire group. So software that we develop in Sri Lanka at Dialogue is being used in Robi Asiata in Bangladesh, in Excel Asiata in Indonesia, and Celcom Asiata in Malaysia. And that's all through, good engineering practices, good software engineering practices on how we put those together. And they're all, 90% of our software is built on AWS and Google Cloud Platform and things like that. So really what you need is the people. know how to use these systems and put it together into something that's useful for you.
Yes,
Yeah. So I'll ask, no one should answer that. And we have about 5 questions from online participants, which we'll take after that.
Yeah, I have a comment to Kapila, right? Yeah. So like Ramesh said, a lot of it's difficult to kind of take technology that worked in one place and like supplant it here. There are nuances that apply to Sri Lanka. Also, I think also there's a problem that we need to solve. There are so I'm now speaking from a startup ecosystem point of view. There are a bunch of startups which are trying to solve AI problems in Sri Lanka, but they have a brand problem, meaning that a lot of our Sri Lankan companies in particular are afraid to sort of use their software, or they just don't have a brand. So many companies tend to go with foreign products which might not be good, as opposed to going with a Sri Lankan startup. So I think there are 2 opportunities there. Which is one is for our private sector in particular to give local startups a chance. That is something that personally I've been trying to evangelize, try to get like, okay, these guys are new, so give them a chance. That's one thing. The other thing is, I think what an organization like the NSF and the government can do is to actually help to create their brand as well. And that one thing that they can do is for at least for state government departments and so on, go with local software. Like why do you buy it from overseas when we can build it here? Right? So I think that is the important part as well. We need to like meet somewhere in the middle.
We have a hand raised from Professor Ruchira Kumartunga. Let's see whether Professor Ruchira, if you can hear me, can you please unmute? Basically, what she asked was about fisheries and marine conservation.
Hello, thanks for giving me an opportunity. I'm a biologist. Actually, I was wondering, now in Sri Lanka, we have fish catch data for many years, especially marine fish catch data. Now there are fishing vessels going to the sea without considering the amount of fish available. That means we are wasting our fuel. So if we can really get the past data and prepare some kind of a plan to decide the number of fishing vessels which should go for fishing at different seasons, and also now fish are available at different strata of the water column, and sometimes their horizontal and vertical distribution can be actually different at different seasons depending on the current pattern and all. So if we can get the fish catch data from the past and develop some kind, actually can you use AI to develop some kind of a model to decide on the number of fishing vessels which should be operated at a given time, and also where these fishing vessels should be operated, and also the type of fishing gear, because depending on the depth, different kinds of fishing gear are used, type of fishing gear to be used. Then actually, especially Sri Lanka is surrounded by the sea, and at the moment actually other countries are fishing, other nationalities are fishing in our waters, especially in our actually EZ, there are other vessels coming. Now recently there was a Chinese research vessel came in, and we don't know what information they collected. So actually for the security of our resources, we should be able to have some kind of artificial intelligence to manage our fisheries, because actually our future lies in the sea, because we are now looking about at the blue economy. So can't we have your support to have some kind of a system to manage these things? And also now very recently there were several ship accidents, and now for us to claim for these damages done, they ask us to relate the number of turtles killed to the ship. We have to prove that this happened because of the ship, okay? Because we have not collected the past information. We don't have these variations in seasonal data. We don't know about the variations in seasonal data. So if we can really have to
Fascinating.
It is most certainly possible. There is no barrier to what you can do, and I think everything that you mentioned here can be done, and it's all about the data. But the challenge here is that this is not one system that has to be built. It's a number of systems which need to be built and then brought together to solve this larger problem. So I think answering your earlier question as well, I think one of the biggest obstacles to machine learning research in Sri Lanka at the moment is the availability of data that was pointed out earlier as well. And the Sri Lanka still runs on this thing of you develop a data set and you run one research project and it's all self-contained within that. But the new model around the world is where one research project may be building a data set, and then you make that data set available to 1,000 researchers and they will do 1,000 different things with it. So in terms of the NSF, maybe one of the biggest contributions you can make to the country at the moment is to put together data sets like this, where you collect this data set and make it available to researchers, and then everything from the NSF to university lecturers to students can start to attack the different small parts of putting a larger system like this, understanding what times to send the boats out, the number of boats out, the depth, the type of tools to use. Each one of those will be a separate micro problem, which when put together will solve a huge problem, but it can't be attacked with one project. And the start for that has to be where we build a high quality data set and then make it available to research. And that is, there's so many examples like this in agriculture, in health science. I mean, there's still not a single kidney patient database in Sri Lanka. It's one of the biggest problems in Sri Lanka going, but there's not. I've been talking to a lot of people. We are trying to start a project, but it's all in different medical faculty lecturers' laptops all around the country. Nobody's created one, and if we had that, we'd have probably made great strides going forward. So in terms of NSF as a facilitator, probably the greatest thing you can do is to put these data sets together, curate them, make sure they are high quality, and continuously keep growing them and make them available for people to do their projects on.
Can I add another thing? Now these days there are marine mammal accidents because of the ship route. Okay, if we can really have some kind of data system to say that at this particular time these mammals are available at a certain GPS position, and then the ships, if we can really give that signal to the ships so that they can avoid these mammals and reduce the number of accidents to these large mammals. Actually, we have to conserve them. So there are many things happening in the ocean, but we have no control over it because we have not really managed this data properly. So I think you all should really help the biologists to do something about it, because this will be very helpful in future for fisheries, tourism, everything. I think it will be very helpful.
Thank you very much, Ruchira. Yeah, I'm going to hand the mic over to Nuan for his response.
No, I have two comments. One is actually for the NSF. I think annually you publish a book called The Natural Resources of Sri Lanka, and I think fish is a natural resource. So that's something that falls into this. And to Ramesh's point, I think something really useful is if we can have some kind of a digital version of that book. Now that book has some, I think the last book version I saw was from 2018 or something like that, but that book has some very rich data sets that are useful for many people. Fish is just one of them. So I think I'll be happy to collaborate if we can make that digital, and so many more people can use it. So that was one comment. The other comment to Ruchira's question was that I think this is this fish issue is something that we should worry about, I think, more than we are doing at the moment, because while Sri Lanka is not using AI, other countries are, like India, for example. So they have some trawlers which detect the location of ships using some very sophisticated techniques, and they are already depleting our fish stock. So before we know it, like AI will be useless if there are no fish. So that is something I think there should be more urgency on.
We have a question posted by Professor Rohan Samarajiva. Unfortunately, he is not on board right now. The question is, any thoughts on the effects of the Personal Data Protection Act that will come into effect next year on access to data for training narrow AI? And the second part is use of cloud services.
Anyone has gone through the act, the Data Protection Act? It
The gazette has already, it has already came out. So I think like we do have a problem to gather the information. And I do have another question. So as we all are agreeing, we don't have a capable teams, the people, even in our school curriculum. So what are the actions that as the NSF that we can get supported to introduce the AI curriculum, and to improve the competencies of the people?
As far as introducing AI into the school curriculum is concerned, of course, that would have to be done through the National Institute of Education rather than the NSF. But of course, if they want to do that, the expertise clearly exists. We can certainly help out. Of course, at the university level, we would all like to see AI being made more available, courses in AI to train personnel, because it really seems to me, and I'm not an expert on AI, that we have a human resource problem, among other things, as well. So hopefully those things will happen. As far as the question itself was concerned, I don't know whether anyone here has the expertise to actually answer it, but we will certainly make note of the fact that that act is going to be passed and will have an effect on what we do. Do we have any other questions from online? Because we have someone.
actually initially they discussed with us also about the implications of this, and we said that it should not stifle our, it's the same issue as AI ethics. I mean, if we make our data protection really strong now, when all the other countries have already done their NIC and all those databases, then we may get into trouble. But yeah, I haven't seen what was finally gazetted to make a comment.
Yeah. Finally, thank you for the great session today. I'm Miller Ajendran from SenseMate IoT Intelligence. Basically, we are one of the companies who are making AI to bring foreign exchange in this country. So the important problem, as Mr. Nuwan said, we're working on agriculture technology. So that's the suggestion I have it for Dr. Gunaratna in terms of working out, because of securing the food security is one of the key, and making sustainability in terms of food. For the first time in, I think, 4 or 5 decades, we started to import rice from Burma and so on. So we have a huge crisis in terms of food security. So I own the company Sense Agro, which is an international agri-tech company based out of Sri Lanka with 88 engineers from Moratu and so on. So basically our main goal is to bring more food security related researchers, how AI and technology can imply onto it, because it was a important demand. And so we just get to know about this forum today, but for last month, we launched a program from our organization where research institutions can be collaborate with us. We provide the technology which is they are lacking of, and since they are agronomists and agronomy is their core area, we are specialized on precision agriculture technologies and drones and so on. So so far we signed up with 4 universities in terms of implementing different crop specific intelligence, doing biological researchers, creating incubator type of environmental climate smart agriculture technologies and so on. So I think there is a huge opportunity and it's a demand to produce from starting from seed selection to value-added services, finally into the food wastage on the last mile section. So for an example, like private sectors doing a huge researches, the country having like 30% waste on the last mile, Keels itself have 4% last mile by doing a small crater based unit quantifying. So those are small researches we can do and apply to save huge billions of dollars on that context. So that's my suggestion. But to the entire forum, so I'm not sure whether you are aware of it. We just got a bill that ICT are going to be abolished by next year. So unfortunate, we're talking about the Sri Lanka and Singapore and so on. So we are in a different pathway going backwards. So this type of research on the right area is ultimately important. So ICT is no more from next year onwards, for your context.
So both the agriculture one and the fisheries one, I think we need to follow up on. Yeah, thank you for sharing that.
Yeah, so when Dr. Ranavana talked about about Singapore as an example, Dr. Gunaratna asked, is there any initiative in Sri Lanka that we can, adapt? So I think that is one of the most important question that we should be answering in this forum. Otherwise, I mean, we'll just all go home and then nothing, right? So I mean, I have few suggestions, but before that, let me give me some examples. So one speaker said some of the African countries are much ahead of us. I mean, that is not just a mere coincidence, right? So in Africa now, there are community level engagement to take AI into the next level. One good example is the Masakane initiative, which is created by, it is mainly for natural language processing. It comprises of linguists, AI, engineers, students, data creators, journalists, everyone who work together to create data for the African languages. And it was started in 2018, and we did a small analysis about the growth of research for such languages like Hausa and Swahili. There's an exponential growth after Masakane was started. So Singapore did it in kind of a monolithic way where the government intervened, but in Africa, mostly it is done by the community up. And they have an yearly meetup called Deep Learning Endeavor, where all the African researchers working in the area of AI meet and discuss what they do. In contrast, in Sri Lanka, we don't have anything like that. We tend to work in silos. So the research paper, the survey paper I mentioned earlier, I think everyone must have a look at it. At the end of that research paper, Dr. Nisans has produced a nice visualization. He has extracted the affiliations of researchers who produce NLP research, and he has created a linked graph. It has created very nice set of linked graphs. So Morotua researchers working in their own silo, UCSC working in their own silo, likewise. So there's no interaction. So I have been working in NLP for, I don't know, maybe 8 years, and Dr. Ruan for, I don't know, maybe long time, but we have never produced anything together. But if you look at USA, if you look at those research papers, there are in single research paper, there are authors from China and Denmark and UK, USA, all around the world. So where are we? Right? So I think partly we are to be blamed for the state of AI in this country, right? Our attitude has to be changed, our methods, our everything has to be changed. And in going forward, I suggest maybe the first step of this discussion would be to set up something like a mailing group, right? To share what we know, what we do, what we create, right? And then everyone will know what is going on. And then Professor Ruchira's project is an excellent need of AI, right? And if we can get her in, we can have multidisciplinary research, right? She gives the biological knowledge, and someone will do the setting up the IoT system, and we can do the data analysis. The system is there, and data creation is paramount, very important. And over the world, it is considered the #1 priority. And it takes time, it takes money, but the good thing is there are research grants. So I'll like to share the good news that last week I got a research grant from Google, $35,000 just to create data. We are going to create parallel data across Sinhala, Tamil, English across about 10 domains, and we say we are going to release it publicly. Anyone can use it, right? And then we are going to train a machine learning, machine translation model for our languages. So we got the grant, right? So it is possible if you say you are going to create data and show that there's a real need, right? And especially the Professor Kumartunga's need is, I mean, you can easily win a grant to create data. So I mean, look around, go to the world, look at the international forums. I mean, we can do that. So as the NSF, take an initiative. And another thing, so the Google grants said, this is an unrestricted gift. We don't expect anything from you, but we just expect that you will acknowledge us in your publications. So it is a very good wake-up call for all the organizations that issue grants, who put all the restrictions in the world when they give a grant. So, I mean, we have to learn from all these institutions and what is happening around the world to take our level of AI further. Thank you.
Thank you for the comments. Do we have any more questions from online participants?
It's rather a comment for a previous discussion from Dr. Lalita Liyanage. Currently in China, robots are replacing the jobs on manufacturing floor. So currently have data on how AI will impact jobs. And there's another comment from the same person about the creative work. If someone has written extensively, can his works be used to train a language model to create works even after the author's demise? How ethical will this be?
I think it's related to the question that Surangika asked about art. So in the past, how people have dealt with text is that text derivative works can be shared, but the source sometimes may not be able to be shared. So yeah, so I think the licensing of data also is an issue. So that's why Lawrence Lessig and his group brought up this Creative Commons, so that you can license data in a way that can be used and not be kind of copyrighted and kind of blocked. But yeah, I think it very much depends on the license. Yes.
Yeah, when it comes to drones, it may be not directly related, but we had a lot of restrictions, as he said, like as a government, like influential body, like for some areas, like for example, if you want to, especially in agriculture field, maybe whole paddy land maybe belongs to me or like some private party. So can't we get like special grant or something because I have the total control over that particular place. So I can be sure that there will be no humans or like anyone will be in that particular area, and maybe we can have access. And other thing is, like when we have sort of delivery systems, we can have special routes for these like plane routes for like through over the ocean and things like that. So can't we influence the government to change these laws at least because it can be immediately implemented, like because there are some things which we have to wait for a long time, and because like spreading up this pesticides and all this stuff is very practical in large farms like
I think currently the people who use this most are those wedding photographers. They go and do these things, and also people who make websites, right? They survey the whole thing and put the website. Yeah, so that's so what Ramesh was saying is that our regulation process is not really going anywhere, and in the absence of that, it's the military who say how you can and how you can't use them, and they say you can't come to this area, high security zone, and so on. Yeah, no, I'm saying there's no regulation right now except that what is by the military. Yeah.
can't get practically, you can't bring it on.
Yeah.
Because of that, hardness, it will be illegal. So
Yeah.
when people try to do it illegally, it becomes illegal.
Anyway, we can record this also as some, and see what we can do and raise a voice or something like that.
I think Ramesh mentioned that he was making the comparison to India, and one important convenience is that they have a website and an app to do this. While here we need to send an email, and then so I think it might not actually be a legal problem. There might be a technical solution to this problem.
Let's hope so. Can we take one more question online and then we'll get back to you? Yes. That's it? Okay, your question.
Why drones and applications of drones.
Paddy fields and so on. So we were working on it for corn and soya with CBL and stuff, even for Triposha cultivation stone. So the biggest barrier of Sri Lanka and agriculture drones is the smallholder farmer ecosystem. So we can't take off a drone without spending at least 1,000, at this point of time, at least 1,200 to 1,500 rupees per acre. So an individual in Sri Lanka own only 0.8 acres. So we're supposed to have a large set of land space to kick off some kind of research on that kind of context. So, so companies. Yes, so not individual can make this decision. Exactly. 50 acres is the minimum. So farmers at least supposed to pay a minimum of 1,500 rupees to take a drone up. So if you're doing spraying, then it's cost another 2,300. So the biggest problem of applying technology for monoculture crops in the country is the per hectare scope of per square feet of cost is very high, where the smallholder farmers cannot be affordable. So they have to create a FPO type of an ecosystem. So to create like hundreds of people get together and sign up for one particular technology adaptation, and they accept it as a cumulative number. With Sri Lankan mentality, it's never happens for us in last 8 years. Yes, because that was in the last generation. So the problem of adapting new technologies, people don't understand. They want to experiment, first of all, by seeing things and going up. So the biggest barrier for monoculture crop, they're making only 60,000 per acre maximum profit out of all the expenses per rotation. That means it's around 3 months to 4 months, 60,000 means 20,000 per acre. So they don't have any margin in between to spend on technology which can adapt it and even improve. Even if it's improved, let's say 20%, that 20,000 per month, it's add up maybe 4,000 rupees. That's all. So that 4,000 rupees adaptation on monoculture and low value crop is not enough for technology adaptation. That's where all the technology implementation happens in Sri Lanka from us or Dialogue or other companies, only in high value crops, especially on greenhouses, horticulture environments and perennial crops like mango, coconut type of environment, where per square feet margin improvement, which is financially high. There's no restriction in terms of technology. It's all about the adaptation and acceptance of the farmers and the affordability. So that would be a challenge. Until farmers get together and make, it won't happen in the monoculture environment. Very, very hard.
So this seems to be like, I mean, at least as a pilot or some
Yes,
project where companies like you kind of where area you're working, you have either the private public partnership or kind of technology grant kind of thing, where there is funding from the NSF also.
This year we invest our own money of 20 million rupees on researchers. So that purely happens on corn and soya. Fantastic results, but then except for CBL, CRISPR and few other companies, there's no other companies of scale in Sri Lanka is almost zero for us. So we stopped those researchers in monoculture and we more focused on horticulture because of purely on this adaptation acceptance. It's because of private sector sustainability mode. So and current crisis plays a huge role on the agriculture for technology adaptation. Farmers' priority change drastically. Fertilizer, combined harvester fuel, then the labor shortage and people going migration. So all those things applies a lot. So technology adaptation in terms of agriculture, maybe 4 or 5 on the priority list. So as a acceptance, we also forced to move out out of Sri Lanka in terms of implementing technology. Within 6 months, we are in 6 countries, but Sri Lankan adaptation almost zero in terms of growth compared to the last after April.
Are there any other questions from the audience? Because we are getting close to 6 o'clock, so we need to wind things down. Yes.
Yeah, just a quick suggestion, because there's a saying that says that 13 years needed to change the attitudes and the thinking of a generation. So I would like to propose and suggest that we will take formal kind of steps to integrate AI into our education system, so that at least in a decade we'll be able to see some kind of fruitful happenings and attitudinal changes and other things in the society. Thank you. That's just a comment.
I would certainly like to second that proposal. Yes, ma'am. Please make your comments rather quick because we need to wind this up.
Just few suggestions. So if you can set up a mailing group, that's fine. But I would like you to look at the AI for Bharat initiative. That is an initiative in India where researchers themselves got together and created the platform where all the data sets, tools, models are kept in one place for all the Indian languages. So if we can also create some kind of such a portal, maybe sponsored by NSF, I think that would be a great, like one stop for everyone for all the data model and code needs for our country. And then another thing is, if you can have some forum, yearly forum where researchers from different universities, industry can meet and discuss what they are doing and their research, what they have achieved. I think that will increase the multidisciplinary research across universities and across the industry and academia. I think that will be a big catalyst to move the, our this industry revolution.
There aren't any fora like that at the moment. No national conference like that.
There's nothing. So there are conferences, that's it. But some, very informal forum where people can meet and discuss, I don't think there's anything. So there's this AI for Asia summit, something like that. I think it's more for formal way. So have a very informal way gathering every year where people meet and talk. Not, presentations or panel discussions or anything, just, some way for people to mix up and talk.
I got you. Okay. So thank you very much, all of you. I want to wind this up. I will ask my colleague Ruan to make his comments, and then I will just say a few final words.
Yeah, so I have noted down several of these things. One of the things that didn't come up very clearly here was, of course, the whole I still remember when we tried to introduce internet here, the universities were paying telephone bills in the thousands. But when we said, you need to put some money for the internet, they said, that's for fun, right? So we can't spend for fun, right? And so it was so difficult. It took years, literally. And the only way was to learn to have a throttle. So when the throttle comes on with no bill paid, the academics go and complain to the vice chancellor, and that's how it worked. But now we have a similar thing. The state system allows you to buy any hardware you want, and compute facilities are all hardware, capital expenditure. And these days, of course, that's also a problem. But they will not allow you to buy compute power, to subscribe to compute power. So I think that's something we can, through NSF, kind of make people aware, and that it is an acceptable item. And then, of course, a lot of the things I think that Surangika and also Noan and all, I think NSF may be able to have an initiative on this data repository, data portal kind of thing, and maybe even twist the arm of some of those who currently have the data and who are not sharing it even though they are supposed to. And yeah, and of course, the drone thing, I think I learned a lot from Sense Agro people here. Thank you for doing that. So I think agriculture and fisheries seem to be two things on which, I mean, those are areas where we should really, as NSF, be involved. And so at least some, oh, what do you call those? Landmark or some pilot projects or something to at least show, if there's a showcase, then others will see, wow, this is what we can do. And for that we need a little catalyst, and so we can't expect companies to put money like he has been there for 8 years or something, so he's big enough, but most will not be able to do that. And marrying the other thing is marrying the startups with companies. So companies have the data, but they don't have the expertise, and the startups have this problem of being recognized. And in some cases we have found also sometimes a company can front end these the startups when they go to consult with other companies. So there are lots of opportunities and possibilities. Yeah, thank you.
So just to wind up, I personally learned a lot from today's symposium, and we are supposed to have a way forward at the end of all this. Of course, thinking doesn't clarify when you have to do it on the fly while people are speaking. And I'm sure in future discussions that we have within our committee, more things will come up. But here are some of the things that I gathered out of this. Okay, one is that what the government needs to do is to regulate or deregulate. In some cases, I think it's more deregulation than regulation, but in other cases, there need to be regulations. I personally am not a great fan of government policies that direct research in certain directions, particularly in cutting-edge technologies, where I find that the private sector and even the universities that actually do the work are way ahead of anything the government can think of. But what the government can do is to facilitate, and I learned some of the ways in which the government can facilitate. So developing the necessary regulation is one of those ways, and we will try and do this to the NSF, possibly by coming up with an actual policy and hoping that the government adopts it, but at the very least by proposing a set of guidelines or policy briefs, and hoping that the minister will take it a bit further. Now, where the NSF itself is concerned, Ruan has already mentioned some of those things, so I don't need to repeat them, right? The idea of collecting the data, making the data available, perhaps even initiatives in terms of what kind of research can be funded. Those are things the NSF will be able to do. The last thing I want to mention is that there was a lot of emphasis that several participants placed on the question of ethics. Right? Ethics is a subject that lags behind the development of technology. We develop technologies for which there is no precedent in the past, and the ethical questions that arise from those technologies do not have answers, that they don't develop answers for generations. So this is something that we scientists need to be always concerned about. So I just want to mention something here. This discussion has also happened at the Sri Lanka Association for the Advancement of Science. And that association, I'm a member of that association, is planning another symposium on the ethical implications of artificial intelligence. It may happen towards the end of this month or early next month. So if you are members of SLAS, please sort of keep your eyes open for the announcements. But since all of you have given your information when you registered, we will make sure that the NSF keeps in touch with you. A suggestion was made that we start a mailing list. We will certainly follow up on that. And I will do my best to inform you, or make sure that you are informed when this other symposium takes place, because that could also be an important one for the implications of ethics in artificial intelligence. My last request to all of you is that once we sort of are on a mailing list, please feel free to email your thoughts, your suggestions, your comments, including ones that you have made now and ones that you didn't have time to make because of the limited time. Please send those to the NSF and they can be incorporated into our discussions. So finally, Mr. Anuruddha, do we have a vote of thanks? Okay, so we'll move on to the last item.
Okay, we have come to the end of this program. And we noted some good suggestions and proposals that you put forwarded here, that we will take these suggestions and proposal to our NSF management. So positively, hopefully that these will be, they will consider these positively. So on behalf of the Director General of National Science Foundation, Dr. Sepalika Sudhasinghe, I would propose the vote of thanks on behalf of her. First of all, I must mention the gratitude to those who came for this this event virtually and physically from the respective institutes as per our request. Actually, there are about 60 participants from about 30 institutes. So on behalf of NSF, I'm very gratitude to you all. We noted you were engaging in lively discussions, and there your interest and enthusiasm were clearly seen. So therefore, it is very much appreciated, and big thanks should go to all of you. This meeting could not be conducted if it is not for the support extended by the management of the NSF by approving required funds and providing the other necessary support. Further, I must thank the chairman, Professor Ranjit Sinaratne, and Dr. Sepalika Sudhasinghe, Director General, who gave us the directives and guidance to make this event a successful one. Let me appreciate the effort made by Dr. Ruwan Weerasinghe as the moderator of the event, as also the coordinator of the subcommittee for IR. And I should not forget Dr. Gunaratne, Ranil Gunaratne, as the moderator and who put forward the way forward. And also he is the chairman of our Science Technology Policy Committee. Let me thank all the other members of our 4IR and policy committee as well for their advice and to make this event, their suggestions to make this event a success. Our gratitude should go also to be extended to these three resource persons, Dr. Ramesh Ranavana, Mr. Nuwan Sinaratna, Dr. Ranveer Singha, for their informative and very interesting presentations and sharing their knowledge among us. Special thanks should go for the support of IT unit, administration and finance divisions in their logistical supports. Finally, I must thank Mrs. Dilushi Mursingha, Scientific Officer, the coordinator of the subcommittee on 4IR, and who coordinated this event wholeheartedly and this activity as well. So at this point, I should also mention, I should extend my gratitude to all my scientific officers in the division and management assistants for their dedication and hard work as a team with other activities of the division. So thank you very much for being here with us. Have a nice day. Thank you very much. Thank you.